There is a continent at the bottom of the world that keeps its oldest secrets underwater. If you were to drain the ocean around Australia by about 120 meters, which is roughly what the planet did during the last ice age, you would find something that most people have never been taught about, and that science is only now beginning to fully reckon with. You would find a country twice the size of what exists today. You would find river valleys running through what is now the Timor Sea. You would find a great inland lake system in the center of a landmass that was, by any reasonable measure, one of the most extraordinary places on Earth for a human being to live. And living there they were. Tens of thousands of years before the first pyramid was constructed in Egypt, before the first clay tablet was pressed in Mesopotamia, before the first stone was laid at Stonehenge, human beings were standing on the red cliffs of this ancient supercontinent and watching the stars move overhead. They had names for the stars. They had stories about them. Those stories are, in some cases, still being told today by their descendants, the oldest continuous civilization on the surface of this planet. A lineage of memory and knowledge stretching back 65,000 years without interruption. And then, 12,800 years ago, something happened. What happened is the subject of this story. What happened is the question that archaeologists and geologists and climate scientists and oceanographers are still arguing about in peer-reviewed journals, in conference rooms at Australian universities, in boats dragging sonar equipment across the shallow sea floor of the Northwest Shelf. What happened is written in the sediment layers, in the charcoal deposits, in the bones of animals that vanished almost overnight, in the sudden silence of human occupation sites that had been continuously inhabited for tens of thousands of years. The answer, if there is one, is buried. Some of it is buried under 100 meters of seawater. Some of it is buried in the oral traditions of peoples whose ancestors witnessed whatever it was firsthand. Some of it is written in the chemistry of ice cores drilled from the other side of the world, where a catastrophic cooling event shows up with the clarity of a scar across the record of time. 12,800 years ago, something happened to Australia's first civilization, and for the purposes of tonight, we are going to walk through everything we know, and everything we still do not, about that moment and the world that preceded it. This is not a story about monsters or ancient aliens or conspiracy theories. This is a story about real people who lived in a real place at a real time in history, and about the forces, cosmic and geological and climatic, that may have ended their world as they knew it. It is a story about loss on a scale that is almost impossible to comprehend, and about the extraordinary persistence of memory across 12,000 years of human time. Let the story begin slowly. Let it settle around you the way the night settles over open water. There is no rush here. The past is patient. It has been waiting this long. The people who were here. First, before we can understand what was lost, we have to understand what existed. And what existed in the Australia of 12,800 years ago was a civilization so ancient and so deeply rooted in the landscape that the word civilization almost feels too small for it. The first humans arrived on the Australian continent at least 65,000 years ago, and possibly much earlier than that. The site at Masjid Bebe, in what is now Arnhem Land in the Northern Territory, has yielded artifacts, grindstones, ochre, tools, that date to 65,000 years before the present. This makes the Aboriginal peoples of Australia and their ancestors not merely ancient, but categorically the oldest known population of modern humans outside of Africa. They arrived on this continent before Homo sapiens had even reached Europe. They were here before the Neanderthals had disappeared. They were here before the last ice age reached its maximum severity. For the purposes of understanding what the world looked like 12,800 years ago, it helps to think about what 65,000 years of continuous habitation actually means. It means that the people living on this continent in the period we are discussing were not newcomers. They were not explorers. They were not settlers. They were, in every sense that matters, indigenous to a landscape they had known for longer than any other human population on Earth had known any landscape at all. In 65,000 years of occupation, they had developed complex languages, hundreds of them, forming language families of extraordinary diversity. They had developed sophisticated systems of land management, including the controlled use of fire to encourage new plant growth, to drive animals, to maintain the ecological health of country they understood with the intimacy that comes only from generations upon generations of careful observation. They had developed astronomy, not the casual stargazing of curious minds, but a systematic multi-generational body of knowledge about the movement of stars and planets, encoded in story and ceremony, that modern astronomers are only now beginning to fully appreciate. They had mapped the stars onto the landscape, and the landscape onto the stars. They understood the connection between celestial events and seasonal cycles, between the rising of certain star clusters and the availability of certain food sources, between the phases of the moon and the movement of water. They understood these things the way we might understand the layout of a city we have lived in all our lives, not as abstract knowledge, but as lived, embodied certainty. At 12,800 years ago, this civilization was not in its infancy. It was ancient, it was mature. It had weathered previous climate shifts. It had adapted to the changing conditions of a continent that, for most of its human habitation, was significantly colder and drier than it is today. The people who lived here had seen glacials and interglacials. They had watched rivers flood and dry up. They had watched coastlines recede and return. They were, by any measure, the most experienced human beings on the planet when it came to living in the face of environmental change. And still, something 12,800 years ago appears to have been different. Something appears to have overwhelmed even this extraordinary depth of resilience and knowledge. To understand why, you need to understand the world they were living in. Not the Australia of today, with its familiar coastlines and its interior deserts, but the Australia that existed during the last ice age, a place so different from what we know that it might as well be a different planet. The continent that existed during the last glacial maximum, which peaked around 20,000 years ago, but was still significantly different from today at the 12,800 year mark, is given a name by geologists and archaeologists. They call it Sahul. Sahul was not just Australia as we know it. Sahul was a single landmass that incorporated what are now Australia, New Guinea, and Tasmania, all connected by dry land where there is now open sea. The Torres Strait, which today separates Australia from Papua New Guinea by about 150 kilometres of water, was then a plain of grassland and scrub. You could have walked from what is now Cape York Peninsula in far north Queensland to what is now Port Moresby in Papua New Guinea without getting your feet wet. The Bass Strait, which today separates mainland Australia from Tasmania, was also dry land. Tasmania was not an island. It was a southward extension of the continent, connected by a broad land bridge that crossed terrain that is now under 40 to 70 metres of cold southern ocean. The total land area of Sahul was approximately 10 million square kilometres, roughly double the land area of present-day Australia, and all of it, or very nearly all of it, was inhabited. The implications of this are staggering, and they are implications that mainstream archaeology has been relatively slow to absorb. If the land area of the continent was twice what it is today, and if that land was inhabited throughout, then a very significant proportion of the archaeological record of ancient Australia is currently sitting underwater. The coastal settlements, which, as in every human civilization throughout history, were almost certainly some of the densest and most complex, and they're gone. The river mouth camps, the estuarine fishing settlements, the coastal middens, the ceremonial sites overlooking what were then productive and biodiverse coastlines, all of it is under the sea. This is not a minor qualification. This is an enormous structural gap in everything we think we know about ancient Australian civilization. We are reconstructing a picture of this world from the surviving inland sites, which were almost certainly not the most complex or the most densely populated parts of the continent. We are, in a very real sense, reading the story of ancient Australia from its footnotes, because the main text has been submerged. At 12,800 years ago, the sea level was still substantially lower than it is today, but it had been rising steadily since the end of the glacial maximum. The ice sheets were melting. The meltwater was flowing into the ocean. The coastlines were retreating inland at a rate that, in some low-lying areas, may have been measurable within a single human lifetime. In the shallow waters of the northwest shelf, where the seabed slopes very gently, a 1-meter rise in sea level can translate to a horizontal retreat of the coastline by many kilometers. The people who lived on those coasts knew about this. Their oral traditions, many researchers now believe, encode the memory of this process. But whether the sea level rise of the early Holocene was the catastrophe that ended the world of Australia's first civilization, or whether something else, something more sudden and violent to ours was responsible, is one of the central questions we will be exploring tonight. The languages that mapped a world one. Of the most consequential things we know about the civilization of ancient Australia is the extraordinary diversity of its languages. At the time of European contact in 1788, there were estimated to be between 250 and 500 distinct languages spoken across the continent. Some sources suggest even higher figures, belonging to multiple distinct language families. The exact number is difficult to establish because many languages had already been lost by the time serious linguistic documentation began, and because the distinction between language and dialect is not always clear. But even the most conservative estimates reveal a linguistic diversity that is, by any global standard, extraordinary. To put this in perspective, Europe, a continent comparable in size to Australia, had at the time of Roman expansion roughly 24 language families. Australia had more linguistic diversity packed into its continent than existed in all of Europe, and possibly all of Asia west of China, combined. This diversity was not the product of recent migration or population mixing. It was the product of tens of thousands of years of populations living in distinct, relatively bounded territories, developing their own linguistic traditions, their own ways of encoding the knowledge of their specific country into the structure and vocabulary of their specific speech. Languages do not merely convey meaning, they structure thought. They determine what distinctions are easy to make and what distinctions require effort. They embed in their vocabulary and their grammar and their categories a particular way of attending to the world. A language developed over thousands of years in a specific landscape will inevitably be rich in exactly the distinctions and the knowledge structures that are most relevant to understanding and living in that landscape. The extraordinary linguistic diversity of ancient Australia was, therefore, not just a cultural curiosity. It was a vast, distributed knowledge system, with each language family serving as a repository of accumulated, refined, tested understanding of the specific country it had evolved within. The loss of languages that has occurred since European contact, estimated at around 200 distinct languages, with many others severely endangered, is not merely a cultural tragedy in the abstract sense. It is an epistemic catastrophe, a loss of knowledge about the Australian environment that took tens of thousands of years to accumulate, and that cannot be reconstructed from any other source. When a language dies, the specific ecological knowledge embedded in its vocabulary goes with it. The names of plants that encode information about their medicinal or nutritional properties, the grammatical structures that encode relationships between species and seasons, the stories that encode the geographical memory of country in a form that is inseparable from the specific sounds and rhythms of the words themselves. This is worth understanding when we think about the world of 12,800 years ago. The people who were living through the events of that period, the rising sea, the changing climate, the disappearing animals, the possible catastrophe from the sky, were not a single people with a single culture. There were hundreds of distinct peoples, speaking hundreds of distinct languages, with hundreds of distinct ways of understanding and responding to their world. When we speak of Australia's first civilization, we are using a singular that conceals an extraordinary plural, a constellation of distinct cultures, linked by trade and ceremony and kinship networks across vast distances, but each with its own particular way of being in the world. Some of those ways of being were better suited to the specific challenges of the Younger Dryas transition than others. Some of those language groups, in some of those regions, may have experienced the transition more severely than others. The responses may have varied: increased mobility in some groups, increased sedentism in others, intensified ceremony, altered trade routes, new technologies for exploiting the resources of a changed landscape. We cannot reconstruct this variation with any precision from the current evidence, but we should hold it in mind because it is a reminder that the story we are telling is not a single story. It is a many-layered, multivocal, deeply complex story, unfolding simultaneously in hundreds of different places and hundreds of different ways. What unites the story is the scale of the transformation. Whatever specific form it took in specific places, the Younger Dryas transition was a continent-wide event, affecting every language group, every ecological zone, every human community from the coastal plains of the north to the cold southern margins of Tasmania. No one escaped it. No one was untouched by the rising sea, the changing climate, the disappearing animals, the transformed landscape. The diversity of responses was real and important, but the shared experience of an extraordinary disruption was equally real, the world that has been swallowed. There is a region of seafloor off the northwest coast of Australia, in waters that are today between 50 and 150 metres deep, that geologists refer to as the Northwest Shelf. From the perspective of Ice Age Australia, this shelf was not seafloor at all. It was one of the most productive and biodiverse regions on the entire continent. A broad coastal plain cut through by rivers, dotted with estuaries and lagoons, rich in the kinds of resources that draw human populations the way gravity draws water. The rivers that ran across this plain are still there, in a sense. They are now submarine canyons, their old courses traced in the shape of the seafloor, the way the outlines of ancient streets can still be seen from the air in a city that has been built over and rebuilt a dozen times. The canyons of the Bonaparte Basin, the Rowley Terrace, the channels that ran between what are now the Kimberly coast and the Timor Sea. These are the ghost rivers of a world that no longer exists above water. What would this world have looked like to the people who lived in it? We have to reconstruct it from the sediment cores that oceanographers have drilled from the seafloor, from the pollen records preserved in ancient lake beds, from the fossil records of plants and animals that no longer exist in Australia or anywhere else. The climate of Australia during the late Pleistocene and early Holocene was complicated. The interior of the continent was, for much of this period, drier than it is today. Not a gradual aridity, but a genuinely harsh, arid zone that may have been largely uninhabitable for extended periods. But the coastal margins were different, particularly on the northern and northwestern coasts, where monsoonal rainfall systems delivered seasonal rains, and where the sheltered estuaries and coastal plains created conditions for extraordinary ecological productivity. The land was rich. It supported large animals, it supported dense plant communities, and it supported human beings in significant numbers. The megafauna of Ice Age Australia, the giant mammals and reptiles that shared the continent with the first Australians, are a critical part of this story, and we will return to them at length. But for now, the point to hold in mind is simply that the world of Australia 12,800 years ago was not the stripped, diminished world of today. It was a world of extraordinary ecological complexity, a world that had been shaped over tens of thousands of years by the interaction between human beings and the landscape they managed, a world that was, by the standards of what came after, extraordinarily alive. The great inland lakes of Australia, now salt pans or dry depressions in the landscape, were then filled with water. Lake Eyre, which most Australians know as a vast salt flat in the arid centre of the continent, had experienced significant wet phases during the Pleistocene. The Willandra Lake system in what is now Western New South Wales, the region where the famous Mungo Man and Mungo Lady were discovered, representing some of the oldest human burials ever found anywhere in the world, was then a chain of interconnected freshwater lakes fed by the Lachlan River, teeming with fish and surrounded by the middens and campsites of people who had lived there continuously for 40,000 years. Mungo Man and Mungo Lady, whose remains date to between 40 and 42,000 years ago, were buried with ceremony. Mungo Lady was cremated, the oldest known cremation in the world. Mungo Man was buried with his hands crossed over his pelvis, ochre sprinkled over his body. These were not the burials of people without culture, without ritual, without a conception of death and what might lie beyond it. These were the burials of people with a rich inner life and a sophisticated social world. 40,000 years after those burials, their descendants were still living in this landscape. They had watched it change. They had adapted to the cycles of wet and dry that governed the behavior of the lakes. They had developed ceremonies and stories that encoded knowledge about where to find water in a drought, about which plants to eat in a lean season, about how to read the signs in the sky that predicted the coming of rain. And then, at 12,800 years ago, the world they knew began to come undone in ways that were, perhaps, different from anything they had experienced before. The evidence for this is spread across the continent, buried in the sediment and the charcoal and the pollen records, and the bone deposits of dozens of sites. It is the kind of evidence that requires interpretation, that is subject to debate among scientists who have spent their careers studying it. But the outline that emerges from all of this evidence is of a world undergoing multiple simultaneous stresses at a scale and speed that tested even the extraordinary resilience of a people who had been adapting to environmental change for 65,000 years. The giants who vanished, if you were to walk through the Australia of 40,000 years ago, you would share the landscape with animals that no longer exist anywhere on Earth. Not just the familiar megafauna of popular imagination, the woolly mammoth, the giant ground sloth of the American continents, but creatures that were unique to this island continent, products of millions of years of isolated evolution, animals that existed nowhere else in the world and that are now gone. The most iconic of these is Diprotodon optatum, the largest marsupial that ever lived. Diprotodon was built like a wombat that had been scaled up to the size of a hippopotamus, a broad, low-slung creature weighing up to 2,500 kilograms, browsing its way through the woodlands and grasslands of late Pleistocene Australia. It was the largest marsupial ever to walk the earth, and it was also, in a sense, one of the most Australian of all animals, a creature shaped entirely by this continent's unique evolutionary trajectory, something that could only ever have existed here. Walking alongside Diprotodon, you might encounter Procoptodon goliah, the giant short-faced kangaroo. At 240 kilograms, roughly 3 times the weight of the largest kangaroos alive today, Procoptodon was a creature of considerable presence. Its face was flatter than any living kangaroo's, its forelegs long enough to reach high into the branches of shrubs and small trees. Where modern kangaroos have 2 functional toes on their hind feet, Procoptodon had one enormous central toe, like a giant hoof. It moved differently from any living kangaroo, and it occupied a different ecological niche, a high browser, taking food from places that the smaller macropods could not reach. There was Genyornis newtoni, a giant flightless bird standing more than 2 meters tall, with legs built for running and a bill adapted for crushing the hard seeds and fibrous plant matter of the Australian interior. There was Megalania prisca, a monitor lizard that makes the largest living Komodo dragon look like a garden lizard. A creature that may have reached 7 meters in length and 800 kilograms in weight, the largest terrestrial lizard in the history of the world. There was Thylacoleo carnifex, the marsupial lion, a predator with the most powerful bite force relative to body size of any mammal that has ever lived. Pound for pound, a more formidable carnivore than any cat or wolf. There were 3-meter-tall wombats. There were giant echidnas. There were enormous snakes. There were tortoises the size of small cars. There were tree-dwelling kangaroos with body plans unlike anything alive today. This was not just a rich fauna. It was a fauna of extraordinary ecological complexity, one that had taken millions of years to assemble, and that represented a unique evolutionary experiment carried out by the only large landmass on Earth that had been geographically isolated from all others for tens of millions of years. All of these animals are now gone. The question of when they disappeared and why is one of the most bitterly contested debates in quaternary science, the study of the relatively recent past, and it is a debate that intersects directly with the question of what happened to Australia's first civilization 12,800 years ago. The debate has two main camps, though the reality, as is usually the case in science, is more complicated than any two-camp framing can capture. The first camp argues that the megafauna were hunted to extinction by the first Australians. This is the overkill hypothesis, developed most prominently by American researcher Paul Martin and applied to Australia by researchers including Tim Flannery. The argument is that when humans arrived on any landmass where the large animals had no prior experience of human predators, the animals were naively unafraid, easy to kill, and slow to reproduce, a combination that made them uniquely vulnerable to even a relatively small human hunting pressure. By this hypothesis, the megafauna of Australia were largely gone by around 46,000 years ago, relatively soon after human arrival. The second camp argues that climate change, not hunting, was the primary driver of megafaunal extinction. Australia's megafauna, by this account, had survived multiple previous climate shifts, but the combination of a warming, drying climate and the altered fire regimes introduced by human management of the landscape pushed them over the edge. Their extinction was not a matter of direct killing so much as habitat transformation, a slow erosion of the ecological conditions on which they depended. In recent years, a third possibility has gained increasing support, though it has also attracted considerable controversy. The possibility that a significant portion of the megafauna extinction, particularly the later portion, the extinctions that occurred around 12,800 years ago, roughly coincident with the Younger Dryas cooling event, may have been associated with a cosmic impact event. This is the Younger Dryas impact hypothesis, and it is one of the most provocative and hotly debated ideas in all of quaternary science. The fire that fell from the sky. In 2007, a team of researchers published a paper in the Proceedings of the National Academy of Sciences that set off a scientific controversy that has not been resolved to this day. The paper, authored by Richard Firestone and a large international team of scientists, presented evidence for a cosmic impact event, or more precisely, a cosmic airburst event, at the beginning of the Younger Dryas, approximately 12,800 years ago. The Younger Dryas itself is a well-established climatic event. It is one of the most precisely documented episodes of rapid climate change in the geological record, and it shows up in ice cores, ocean sediment cores, lake sediments, and pollen records from around the world. The Younger Dryas was a period of sudden, dramatic cooling that interrupted the gradual warming trend of the end of the last ice age. Average temperatures in some parts of the northern hemisphere dropped by as much as 15 degrees Celsius within decades, not centuries, but decades. The cooling lasted for approximately 1,200 years, and then, almost as abruptly as it began, it ended and the warming resumed. The mechanism that caused the Younger Dryas is itself debated. The most widely accepted explanation is a disruption of the Atlantic meridional overturning circulation, the conveyor belt of ocean currents that distributes heat around the planet, by a massive influx of cold fresh water from melting ice sheets. The specific source of this fresh water has been proposed as a catastrophic drainage event from the glacial Lake Agassiz in North America, which, at its maximum extent, was larger than all of today's Great Lakes combined. What the Firestone team proposed was that the mechanism for this disruption was not just a lake drainage event. They proposed that a fragmented comet or asteroid struck the Earth, or exploded above the Earth in a series of atmospheric airbursts, at the boundary of the Younger Dryas, and that this event caused catastrophic wildfires across North America, destabilized the ice sheets, and triggered the sudden climate change that followed. Their evidence included a thin layer of materials found at dozens of sites across North America, Europe, and the Middle East, all dating to approximately the same time. This layer contained nanodiamonds, microscopic diamond-like carbon structures that can only form under the extreme pressure of a cosmic impact. It contained spherules of melted iron. It contained high concentrations of platinum and iridium, elements that are rare in the Earth's crust but common in certain types of meteorites. It contained magnetic grains and glass-like carbon. And, most dramatically, it contained evidence of a continental-scale wildfire, a layer of charcoal and soot spread across millions of square kilometers. The Younger Dryas impact hypothesis has been both supported and challenged by subsequent research. Some scientists have successfully replicated the finding of the signature layer at additional sites. Others have failed to find it, or have argued that the materials cited as evidence of impact can be explained by other processes. The nanodiamonds in particular have been the subject of intense scrutiny, Their presence has been confirmed by some research teams and questioned by others. The debate continues. What is relevant to our story is what this hypothesis means for Australia. If a fragmented cosmic body exploded above or impacted the Earth 12,800 years ago, the effects would not have been limited to North America. A large enough event, and the proposed impactor, if real, would have been comparable to or larger than the Tunguska event of 1908, which flattened 2,000 square kilometers of Siberian forest, would have had global consequences. The dust and debris injected into the stratosphere would have affected atmospheric chemistry worldwide. The initial shockwaves, if it was an airburst rather than a ground impact, would have generated heat pulses capable of igniting forests across a broad area. And then there is the question of whether there were fragments of the proposed impactor that struck the southern hemisphere. Australia, in particular, has a sediment record from the Younger Dryas boundary that has not been as thoroughly examined for impact markers as the North American record. What work has been done is suggestive. Platinum anomalies have been reported from Australian sediment records at the Younger Dryas boundary. Charcoal deposits dating to this period are found at sites across the continent. There is a pattern of abrupt change in the pollen records, the sudden dominance of fire-adapted plant species that suggests a landscape-scale burning event. Whether that burning was caused by a cosmic impact, by a dramatic intensification of human fire management in response to deteriorating climatic conditions, or by some combination of both is not yet clear. But the possibility that Australia, already experiencing the stresses of a rising sea and a shifting climate at 12,800 years ago, was also subjected to the effects of a catastrophic cosmic event. If not a direct impact, then the atmospheric and climatic consequences of such an event occurring elsewhere on the planet is one that researchers are increasingly taking seriously. The sea that would not stop rising. Of all the forces that shaped the end of Australia's first civilization, none was more relentless or more certain than the rise of the sea. Sea level rise at the end of the last ice age is not a hypothesis. It is not a matter of debate. It is one of the best documented events in the geological record, preserved in shoreline deposits and submerged terraces, and coral reef cores and glacial ice in Greenland and Antarctica, confirmed by dozens of independent lines of evidence from every ocean basin on the planet. Between the last glacial maximum, approximately 20,000 years ago, and the stabilization of sea levels at roughly their current position, approximately 7,000 years ago, the global ocean rose by somewhere between 100 and 130 meters. 100 meters. Think about what that means for a continent as flat and as broadly shelved as Australia. In some parts of the world, the coastline retreated by hundreds of meters as the sea rose by a single meter. In the shallow waters of the Arafura Sea, which sits between northern Australia and New Guinea, the seabed today is in many places less than 50 meters below the surface. When the sea was at its glacial maximum level, the Arafura Sea did not exist. It was land. The Torres Strait, which today separates Australia from Papua New Guinea, was dry. The entire region was a broad coastal plain of grasslands and woodlands, threaded by rivers fed by the tropical monsoons of the north, alive with the kinds of estuarine and coastal resources that are among the most productive ecosystems on Earth. As the ice melted and the sea rose, this plain was inundated, not all at once, but continuously, inexorably, year after year. The rate of rise was not constant. There were periods of faster and slower inundation, corresponding to the melting rates of the great ice sheets of the northern hemisphere. And there were, researchers have proposed, brief periods of catastrophically rapid rise, events they call meltwater pulses, during which sea level may have risen by several meters within a century or less. Meltwater Pulse 1A, which has been dated to approximately 14,500 years ago, and Meltwater Pulse 1B, which may have occurred around 11,500 years ago, represent two of the most significant of these rapid rise events. Whether there was a similar pulse closer to 12,800 years ago, coinciding with the Younger Dryas boundary, is a subject of active research. Some oceanographers believe the evidence supports a significant acceleration of sea level rise at precisely this period, possibly triggered by a destabilization of ice sheets connected to the same cosmic or climatic event that caused the Younger Dryas cooling. For the people living on the coastal plains of Sahul, a rapid acceleration of sea level rise would have been catastrophic. These were not abstract events happening over geological timescales, invisible to any individual human life. A rise of several meters over a century translates to a loss of coastal land that would have been visible and felt within living memory. In the flat, shallow northwestern plain, a single meter of sea level rise could push the shoreline back by kilometers. A rapid rise of several meters could move the coast so far inland that entire communities, entire networks of settled places, would have been underwater within a generation. There is a specific piece of evidence for this that is both scientifically significant and deeply moving. It comes from the Aboriginal oral traditions of Australia, those extraordinarily ancient bodies of knowledge encoded in story and ceremony that have been passed down across generations, stretching back to a time before any written record existed anywhere in the world. In 2015, a team of researchers led by Patrick Nunn and Nicholas Reid published a study in the Journal of Australian Studies examining Aboriginal oral traditions from across the Australian coast that appear to encode memories of sea level rise. They identified more than 20 distinct oral traditions from language groups spread around the coast of the continent that describe the sea engulfing former lands. Lands that were once inhabited, once productive, once home. These traditions name specific geographical features, bays, headlands, islands, that correspond to currently submerged locations on the continental shelf. Some of them describe events in enough geological detail that it is possible to match them to specific episodes of sea level rise that occurred at specific times. The Yolngu people of Arnhem Land in the Northern Territory, for example, have a tradition describing the flooding of a vast plain in what is now the Gulf of Carpentaria, a body of water that sits today in waters between 50 and 80 meters deep. Geological records confirm that this plain was inundated between about 12,000 and 10,000 years ago. The Narunga people of the Yorke Peninsula in South Australia have a tradition describing a time when Spencer Gulf, a large inlet of the Southern Ocean, did not exist, when it was dry land across which their ancestors walked freely between what are now separated communities. The flooding of that land corresponds to sea level changes that occurred between 12,000 and 9,000 years ago. What these traditions represent is something remarkable, a continuous oral memory of events that occurred 12,000 years ago, preserved with sufficient geographical accuracy to be matched against independent geological data. It is, by the standards of written history, an almost incomprehensible depth of memory. But for people who had been carefully tending and transmitting their knowledge of country for 65,000 years, it may simply be what that kind of knowledge looks like when it survives. The loss of the coastal plains to the sea was not a peripheral event for Australia's first civilization. It was a central one. The coast is where the richest resources were. The coast is where trade and exchange networks converged. The coast is where, in every human civilization we know of, the densest and most complex settlements existed. The flooding of the coastal plains of Sahul removed from human habitation an area of land comparable in size to the entire continent of Europe, and it did so over a period of roughly 13,000 years, a period that, from the perspective of individual human lives and even of many successive generations, may have felt less like a gradual process and more like an unending catastrophe, a world that kept shrinking, kept being taken by the water year after year after year. The animals that disappeared. There is a marsupial the size of a large dog that Australians today know mainly from museum exhibits and fossil illustrations. It is called the thylacine, the Tasmanian tiger, and it survived on the island of Tasmania until 1936, when the last known individual died in the Hobart Zoo. On mainland Australia, where it had once been found across the entire continent, it disappeared thousands of years ago. The story of the thylacine is, in some ways, a microcosm of the broader story of Australian megafaunal extinction, and it illustrates some of the complexity that makes this story so difficult to untangle. The thylacine's extinction on the Australian mainland appears to have occurred around 2,000 to 3,000 years ago, roughly coinciding with the arrival of the dingo, a domestic dog brought by a new wave of human immigration from Asia, and with changes in human land use and management practices. Its survival on Tasmania until the 20th century is explained by the absence of dingoes from that island, but the thylacine was one of the survivors. The giants, Diprotodon, Procoptodon, Genyornis, Megalania, were gone much earlier, and the timing of their disappearance is precisely what is at issue in the debate about what happened to Australia's first civilization 12,800 years ago. The debate about megafaunal extinction in Australia has traditionally focused on two primary extinctions events. The first, around 46,000 years ago, which the overkill hypothesis associates with the arrival of humans, and a second, later extinction pulse that is harder to date with precision, but that appears to cluster around 10,000 to 12,000 years ago, right at the boundary of the Younger Dryas. This second extinction pulse is less frequently discussed than the first, but it is arguably more relevant to our story. Several species that appear to have survived into the late Pleistocene, that is, that were still present on the continent as recently as 15,000 years ago, disappear from the fossil record around 12,800 years ago. The giant wombat-like creature Phascolonus gigas, certain species of giant kangaroo, the large short-faced kangaroo Protemnodon. These were animals that had already survived the first wave of human colonization, that had coexisted with human hunters for tens of thousands of years. Whatever finally ended them appears to have been different from the hunting pressure of the initial colonization. The evidence for what ended them is buried in the same sediment layers that contain evidence of everything else that was happening at 12,800 years ago. The charcoal deposits indicating widespread fire, the pollen records indicating sudden vegetation change, the chemical anomalies in some sites that may indicate a cosmic event, the shifting coastlines recorded in the sediment cores of the submerged continental shelf. Genyornis newtoni, the giant flightless bird, has its own particular story within this broader narrative. Researchers studying Genyornis eggshell fragments from archaeological sites across Australia have found that the distribution of these fragments changes dramatically at a certain point in the record. Before that point, before approximately 50,000 years ago, by some analyses, Genyornis eggshells are found at sites across a wide range of habitat types. After that point, they are absent or very rare in some regions, and their decline appears to be associated with changes in the vegetation record consistent with an intensification of fire regimes. Gifford Miller and his colleagues at the University of Colorado, who have done some of the most detailed work on this question, argue that the burning of the Australian landscape by early human inhabitants fundamentally transformed the ecology of the continent in ways that made it unable to support the giant herbivores. Not by killing the animals directly, but by burning the nutritious, slowly growing deep-rooted plants that the giants depended on, and replacing them with the fast-growing fire-adapted grasses and scrubs that dominate much of Australia today. The continent, by this argument, was ecologically transformed thousands of years before the Younger Dryas, but the Younger Dryas, with its additional climatic and possibly cosmic stresses, finished off the survivors. Whatever killed them, the loss of the megafauna was not just an ecological event, it was a cultural one. The people who had lived alongside these animals for tens of thousands of years, who had incorporated them into their stories, their ceremonies, their cosmologies, found themselves living in a world that was, by comparison with anything their ancestors had known, impoverished. The giant herbivores had shaped the landscape in ways that supported the entire ecological web. Their disappearance cascaded through that web in ways that would have been visible and felt across generations. There is a dreaming tradition among certain Aboriginal groups that describes enormous animals, creatures unlike any living today. There are rock paintings and engravings in various parts of Australia that depict animals that do not correspond to any species currently alive. Whether these represent genuine memory of the megafauna, or whether they represent something else entirely, is a matter of debate. But the possibility that the oral traditions of Australia encode not just memory of landscapes that were submerged by rising seas, but also memory of animals that shared those landscapes before they disappeared, is one that researchers are increasingly prepared to take seriously. The cold that came without warning. The Younger Dryas is named after a small Arctic flower, Dryas octopetala, whose pollen, found in abundance in the sediment layers from this period in European bog deposits, indicated to geologists that the tundra had advanced southward into latitudes that had previously been forested. The flower was, in a sense, a biological marker of the cold. In Greenland, where the ice core record provides a continuous high-resolution climate archive going back hundreds of thousands of years, the onset of the Younger Dryas shows up as one of the most dramatic events in the entire record. In a matter of decades, possibly less than a single human lifetime, average temperatures in Greenland dropped by between 10 and 15 degrees Celsius. The cold arrived with a speed that has few precedents in the ice core record outside of truly catastrophic events. For the northern hemisphere, the effects were devastating. Agriculture, which was just beginning to develop in the Fertile Crescent of the Middle East, the region that would eventually produce the first civilizations of Mesopotamia and Egypt, was apparently interrupted. Archaeologists studying the Natufian culture, the complex hunter-gatherer society of the Levant that is often seen as a precursor to the first agricultural communities, find evidence of cultural disruption and population movement that coincides with the Younger Dryas cooling. The early experiments with cultivation that were underway in this region appear to have been set back significantly by the return of cold, dry conditions. The Clovis culture of North America, the first well-documented human population of the Americas, famous for their distinctive stone projectile points, disappears from the archaeological record at precisely the Younger Dryas boundary. The extinction of the North American megafauna, the mammoths, the mastodons, the giant ground sloths, the American horses and camels, occurs at the same time. Whether this is because of the Younger Dryas climate change, because of the proposed cosmic impact, because of human hunting pressure, or because of some combination of all three, is the question that the Younger Dryas impact hypothesis was designed to answer. For Australia, the Younger Dryas effects were different from those in the Northern Hemisphere, because Australia is in the Southern Hemisphere, and because its climate is governed by different oceanic and atmospheric systems. The Younger Dryas cooling was not as extreme in the Southern Hemisphere as in the Northern, a fact that some critics of the Younger Dryas impact hypothesis have used to argue against a single global catastrophic event. But the idea that the southern hemisphere was unaffected by the Younger Dryas is not quite right either. Marine sediment cores from the waters around Australia show measurable changes in sea surface temperature and circulation patterns at the Younger Dryas boundary. The monsoon systems that deliver seasonal rainfall to northern Australia appear to have shifted. In the pollen records from lake sediments in eastern Australia, there are changes in vegetation composition that suggest altered rainfall patterns. The charcoal records show increased fire frequency. These are not the dramatic changes seen in Greenland, but they are real changes, and they were happening in a landscape already under stress from rising seas and, if the impact hypothesis is correct, the aftermath of a cosmic event. One of the most important things to understand about the Younger Dryas in the context of Australia is what it did to water. The continent's hydrology is particularly sensitive to small changes in rainfall. The great inland lake and river systems that had provided reliable water sources for tens of thousands of years of human habitation were dependent on a delicate balance of precipitation and evaporation. A shift in monsoon timing, a reduction in the frequency of the wet season rains, could push a marginal system from productive to dry within a decade. There is evidence preserved in the sediment records of ancient lake beds in both the Australian interior and the submerged continental shelf of exactly this kind of hydrological disruption at the Younger Dryas boundary. Lake systems that had been productive for thousands of years show sudden evidence of falling water levels, of increased dust deposition indicating the exposure of dry lake beds, of the kinds of sediment signatures associated with drought and wind erosion. The landscape that had supported a complex, distributed human population appears to have become, in some regions, significantly less hospitable in a relatively short time. The stories that outlasted everything, there is an argument in philosophy about whether memory can be considered knowledge. The question is whether something you remember, something your grandmother told you that her grandmother had told her, qualifies as genuine knowledge of the world, or whether it is something more fragile, more subject to distortion and loss, and the accumulated errors of successive transmission. The Aboriginal oral traditions of Australia are, in a sense, the most extraordinary test case for this question in human history. They represent a body of knowledge about the world, about the behavior of the landscape, the movement of the stars, the history of the coast, the memory of extinct animals, that has been transmitted orally across a period of time so long that it makes the entire history of written civilization look like a brief footnote. The evidence that these traditions encode genuine historical memory is not merely theoretical, it is empirical. Patrick Nunn's work on the sea level traditions is the most carefully documented example, but it is far from the only one. Researchers studying Aboriginal astronomical traditions have found that the dreaming stories of many language groups encode accurate astronomical information. The Kamilaroi and ULI peoples of northern New South Wales have a tradition about the Pleiades, the star cluster known in European astronomy as the Seven Sisters, that describes the stars as being chased by a hunter associated with the stars of Orion's belt. This narrative structure is remarkably consistent across many Aboriginal language groups, suggesting that it was established at a time when all these groups were part of a common cultural and geographical community. More remarkably, the story describes 7 sisters, but the Pleiades as seen today with the naked eye shows only 6 stars clearly visible, with a 7th too faint to see without ideal conditions. Research by Dwayne Hamaker and colleagues at Monash University has proposed that the original story, describing 7 visible sisters, may date to a time when the 7th star of the Pleiades was brighter than it is today, a time that astronomical calculations suggest was around 100,000 years ago, when the star that is now too faint to see easily was still within visual range. If this analysis is correct, the story preserves a memory of what the night sky looked like over 100,000 years ago. This is an almost incomprehensible depth of memory. It suggests that the oral tradition of Australia is not merely old, but is old in a way that challenges our fundamental assumptions about what human memory is capable of preserving across time. For our purposes, the most relevant oral traditions are those that appear to describe the events at and around 12,800 years ago. These include not just the sea level traditions that Nunn and Reid documented, but also traditions that describe sudden darkness, falling fire, the death of large animals, the transformation of the landscape. There are traditions from the Aranda people of Central Australia that describe a time when the sky was filled with fire and the great animals of the land were killed by it. There are traditions from coastal peoples of northwest Australia that describe the sea swallowing their ancestors' country in a matter of days or weeks, not gradually, but suddenly, with a violence that the landscape had never previously shown. There are traditions that describe a period of darkness and cold after a great burning, a time when the stars could not be seen and the world seemed to have been remade. Are these traditions memories of the Younger Dryas event? Memories of the cosmic impact, if that is what happened, of the fires it ignited, of the cold that followed, of the sea that rose in its wake? Or are they memories of other events interpreted through the lens of later experience, layered with meanings that are spiritual and metaphorical as much as historical? The honest answer is that we do not know with certainty. The oral traditions of Australia are not easy to decode, and they were not designed to be decodable by outsiders. They contain information in forms that require cultural knowledge to interpret. They are encoded in ceremony as much as in narrative. They are kept, in some cases, by specific custodians whose responsibility is to maintain their integrity across generations. A role that comes with obligations and protocols that have no parallel in the tradition of written scholarship. What we can say is that the traditions exist, that some of them appear to encode accurate geographical and astronomical information about events that occurred thousands of years ago, and that they come from a culture that has been maintaining these traditions with extraordinary care and fidelity for longer than any other on Earth. When those traditions describe catastrophic events coinciding with the period we are studying, they deserve to be taken seriously, not as literal descriptions of specific physical events, but as evidence that something significant happened, something significant enough to be remembered and transmitted and encoded in ceremony across 12,000 years of human time. The archaeology beneath the waves. There is a ship called the Southern Surveyor, and for a period in the early years of the 21st century, it spent time dragging sonar equipment across the seafloor of the Northwest Shelf off the coast of Western Australia. The data it collected, bathymetric maps of the seafloor, acoustic profiles of the sediment layers beneath, began to reveal something that archaeologists had suspected for decades, but had never had the technology to document in detail. The submerged continental shelf of Australia is not empty seafloor. It is a landscape. The sonar data from surveys like those conducted from the Southern Surveyor reveals features on the seafloor that are not explained by simple geological processes. There are formations that look like the remnants of riverbeds, channels cutting through the flat sediment plain that trace the courses of rivers that flowed across this plain when it was dry land. There are features that may be the remnants of shoreline formations, the kind of raised ridges and depressions that form along ancient beach lines. And, in some areas, there are features that are harder to explain by geology alone. Shapes that, when examined closely, raise the possibility that they represent the remnants of human structures or activity. The archaeology of submerged landscapes is a young field, and it faces formidable practical challenges. Working at depths of 50 to 100 meters requires specialized equipment. Visibility on the seafloor is often poor. The sediment that has accumulated over 12,000 years of submergence has, in many places, buried or obscured the features that might indicate human occupation. And the basic logistics of underwater archaeological excavation at scale are orders of magnitude more expensive and technically demanding than their terrestrial equivalents. Despite these challenges, the field has produced results that are changing our picture of Australia's prehistoric past. On the coast of Western Australia, underwater surveys have found stone artifacts on the seafloor in waters that were exposed as dry land between about 18,000 and 7,000 years ago. These artifacts, simple stone flakes and cores that are recognizable as the products of intentional human manufacture, are the first direct evidence of human occupation of the drowned Australian coast. They do not tell us everything. They do not tell us how many people lived there, or what kind of social organization they had, or what they believed. But they tell us that people were there, living on land that is now under the sea. The Dampier Archipelago off the coast of northwest Western Australia is one of the most archaeologically rich regions in Australia, and one of the least well-studied relative to its importance. The islands of the archipelago are the remnant peaks of a coastal landscape that extended much farther west before the sea rose. The rock art of the Burrup Peninsula, now a World Heritage Site, contains tens of thousands of petroglyphs, images pecked into the surface of rocks, that represent one of the largest concentrations of rock art on Earth. Some of these images appear to depict animals that are no longer found in Australia, possible thylacines, possible megafaunal species. If these identifications are correct, they represent visual records of animals that were extinct on the Australian mainland by at least 3,000 to 4,000 years ago, suggesting that at least some of the Burrup art is of considerable antiquity. But the Burrup is also notable for what has been lost. When the sea rose, it submerged the outer portions of the landscape of which the Burrup was a part. The coastal plain that once extended from the Burrup westward to where the sea now is, a plain of unknown extent, unknown ecological character, unknown archaeological richness, is gone. Whatever was there, whatever occupation sites existed on that plain, whatever rock art decorated its outcrops and shelters, is now under the sea, inaccessible, perhaps irretrievably lost. Underwater archaeological surveys are finding that the story of the submerged Australian coast is, in places, the story of landscapes with considerable evidence of past human use. The question is not whether people lived there. They clearly did. The question is what kind of world they built in those places, how complex it was, and what was lost when the sea took it. These are questions that underwater archaeology is beginning to address, but that will take generations of work to answer fully. In the Gulf of Carpentaria, the large, shallow body of water that sits between the top of Australia and the bottom of the Torres Strait, there is a particularly interesting story. The Gulf was, until approximately 12,000 years ago, either dry land or a very shallow, largely enclosed lake. As the sea rose, it flooded from both ends, from the Arafura Sea to the west and from the Coral Sea to the east, transforming what had been a land corridor between northern Australia and New Guinea into a body of open water. The flooding of the Gulf effectively separated populations that had previously been in close contact, splitting communities and language groups that had previously been connected by land into groups separated by open sea. The memory of this connection, of a time when you could walk from what is now Arnhem Land to what is now Papua New Guinea, is preserved in the oral traditions of peoples on both sides of the resulting strait. The traditions describe a time when the ancestors walked freely between what are now separated places, and they describe the coming of the water that divided them. This division was not just a geographical event, it was a social and cultural event of the first order, cutting off exchange networks and communication channels and kinship ties that had maintained cultural continuity across a vast region for thousands of years. The carbon in the soil. One of the most reliable witnesses to past events is also one of the least glamorous. Charcoal, the black, stable residue of burnt organic material, does not decompose. It is chemically inert, meaning that once it is deposited in a sediment layer, it stays there essentially unchanged until someone digs it up or drills through it. It can be dated precisely by radiocarbon methods, and it records, with the fidelity of a geological archive, the history of fire in a landscape. The charcoal record of Australia, around 12,800 years ago, tells a story of increased fire. This is not a subtle signal. In many sites across the continent, the sediment layers from this period contain significantly elevated concentrations of charcoal compared to either the preceding or the following millennia. The increase is visible in lake sediment cores from eastern Australia, in peat bogs in southeastern Australia, in coastal sediment records from around the continent. Something was burning more than usual around 12,800 years ago. The interpretation of this increased fire signal is, predictably, contested. There are at least three competing explanations, and they are not mutually exclusive. The first is that the increased burning reflects an intensification of Aboriginal fire management, a deliberate increase in the use of fire by human populations as a land management tool. This could have been a response to deteriorating environmental conditions, an attempt to maintain or restore the productivity of a landscape under stress. Many Aboriginal fire management traditions involve burning at regular intervals to create a mosaic of different vegetation ages and types, which maximizes biodiversity and the availability of food resources. An intensification of this practice in response to environmental stress would, over time, leave exactly the kind of charcoal signal that is found in the sediment record. The second explanation is that the increased burning was a consequence of the climate changes associated with the Younger Dryas. Changes in the timing or intensity of rainfall can dramatically affect fire risk. A shift to more pronounced wet-dry seasonality, longer dry seasons following by intense wet seasons, creates the ideal conditions for large wildfires. A dry season that desiccates the vegetation, followed by a wet season that produces abundant growth, followed by another dry season that turns that growth into tinder. The climate of northern Australia today, with its strongly seasonal rainfall, is exactly this kind of fire-prone regime, and the Younger Dryas may have pushed the continent's climate more strongly in this direction. The third explanation, the one associated with the Younger Dryas impact hypothesis, is that at least some of the elevated charcoal signal represents wildfires ignited by the heat pulses and the debris from a cosmic impact event. This explanation would predict not just elevated charcoal levels, but a specific pattern of elevated charcoal in a narrow time horizon coinciding with the boundary event, followed by a more gradual decrease as the immediate fires died out and the longer-term ecological effects took over. Some researchers believe this pattern is visible in the Australian charcoal record, but the data are not yet of sufficient resolution to be conclusive. Whatever caused it, the increased burning of the Australian landscape at this period would have had profound ecological consequences. Fire transforms the vegetation mosaic. It can promote or suppress different plant species. It affects the availability of water by changing the water-holding capacity of the soil. It affects the distribution of food resources. And for the people living through it, whether they were the agents of the fire or the witnesses to fires started by other causes, it would have been a defining feature of the world they inhabited during this critical period. The pollen record complements the charcoal record. Pollen from different plant species is preserved in lake sediments in proportions that reflect the composition of the surrounding vegetation. When the pollen record shows a sudden increase in the proportion of fire-adapted species, grasses, certain acacias, the iconic Banksia, at the same time as the charcoal record shows increased burning, it tells a consistent story of a landscape in the process of transformation. In many parts of Australia, the vegetation transition that is recorded in the pollen and charcoal records at around 12,800 years ago represents a shift that did not reverse. The open grassy woodlands and shrublands that dominate much of the continent today are the legacy of that transformation. The deep-rooted, slow-growing, nutritionally rich plant communities that had supported the megafauna for millions of years were replaced progressively by a vegetation type that is ecologically simpler, less diverse in some respects, and less supportive of large herbivores. This was not necessarily a less beautiful landscape, but it was a less productive one by the measure of what had previously existed. There is an archaeological site in the western desert of Australia called Puritjara. It is a rock shelter in the Gibson Desert, one of the most arid and inhospitable regions in a continent famous for its aridity. The shelter sits at the base of a low sandstone ridge, facing east, protected from the worst of the summer heat by the overhang of rock above. Inside the shelter, the floor sediments preserve a record of human occupation, stretching back more than 30,000 years, one of the oldest occupation sequences in the Australian interior, and one of the most complete. The Puritjara record is particularly valuable because it spans the period we are discussing, the Younger Dryas boundary and its aftermath, with enough stratigraphic resolution to detect changes in the intensity and character of human occupation across this critical time. What the record shows is consistent with the broader picture we have been describing, a period of reduced occupation intensity around the Younger Dryas boundary, followed by a recovery in subsequent millennia as conditions gradually improved. But the Puritjara record also shows something more specific and more interesting. It shows that the people who were using the shelter during the most stressed period of the Younger Dryas transition were not simply abandoning their technology or their way of life. They were adapting it. The stone tools of this period showed changes in the raw materials being used, a shift toward materials that could be obtained from sources closer to reliable water, suggesting that the range of movement was being constrained by the drying of the landscape. The tools themselves show evidence of more careful curation, more intensive resharpening, more economical use of stone, consistent with a population that was moving through a landscape where good tool stone was harder to find than it had previously been. This pattern of adaptation rather than collapse, of careful response to changing conditions rather than passive suffering, is visible at other interior sites as well. It is consistent with what we would expect from a people who had been adapting to the variable and sometimes extreme conditions of the Australian interior for tens of thousands of years. The Younger Dryas was not, for the people of the interior, something entirely without precedent. They had seen droughts before. They had adapted to previous periods of reduced rainfall. They had the knowledge and the technology and the social networks to respond. What was different about the Younger Dryas was the combination of stresses arriving simultaneously, and the possibility that the magnitude of the disruption exceeded anything in living memory or even in the oral tradition. A drought that lasted a generation, and another, and another. Not the seasonal dry that could be managed by moving to the water, but a structural shift in the rainfall regime that persisted for centuries. A coast that kept retreating year after year, denying the inland populations the coastal resources that had provided both food and the social connections of trade and exchange, and perhaps the addition of a cosmic event whose direct and indirect effects compounded the already significant stresses of climate change and sea level rise. The dry heart of a flooded world. There is an apparent paradox at the centre of this story. On one hand, Australia's coasts were flooding, being taken by the rising sea. On the other hand, Australia's interior was, in many places, getting drier, not wetter. The continent was simultaneously losing land to water at its margins and losing water from its interior. How do you understand this contradiction? The answer lies in the difference between sea level change and precipitation change. The rising sea did not mean more rain. It meant that the ocean was rising because ice was melting elsewhere, in Greenland, in Antarctica, in the great ice sheets of the northern hemisphere. That meltwater was entering the ocean globally. The rain that fell on Australia, the monsoon rains of the north, the westerly-driven storms of the south, the convective storms of the interior, was determined by different factors. By the temperature of the surrounding ocean, by the position of the subtropical high-pressure belt, by the behavior of the large-scale atmospheric circulation systems that distribute precipitation around the southern hemisphere. During the Younger Dryas, these systems appear to have shifted in ways that made parts of Australia drier, not wetter. The monsoon rains of the north may have been weaker or less consistent. The westerly storm systems of the south may have tracked farther south, bringing less rain to the southeastern interior. The interior lake systems that had been maintained by a combination of long-distance runoff and direct precipitation may have begun to fail, first drying at their margins, then contracting, then disappearing. Lake Eyre is perhaps the most emblematic example. The Lake Eyre Basin, the largest drainage basin in Australia, covering about 1/6 of the continent, had experienced significant wet phases during the Pleistocene, when the lake held substantial volumes of water and supported productive ecosystems. The transition to the hyper-arid conditions that characterize the region today was not instantaneous, but it appears to have accelerated significantly during the Younger Dryas and the early Holocene. The records from lake sediment cores in this region show a shift around 12,000 years ago toward the dry and dusty conditions that prevail today. For the people who had been living in and around these interior lake systems for tens of thousands of years, the loss of reliable water was a fundamental challenge. Water is the limiting resource in an arid environment. Where water was available, around lakes, along rivers, at springs, populations could concentrate and sustain complex social lives. Where water was absent, the land could support only the most mobile and dispersed of populations, people who had to cover enormous distances to access scattered and unpredictable resources. The shift toward aridity in the Australian interior during and after the Younger Dryas represents a contraction of the habitable world. Not an absolute contraction, people continued to live in these landscapes, as the archaeological record attests, but a contraction in the sense of a reduction in the carrying capacity of the land, a reduction in the number of people that a given area could support, and therefore a reduction in the complexity and density of the social networks that depended on that carrying capacity. There are archaeological sites in the Australian interior, cave sites, rock shelter sites, open-air sites along the edges of now dry lake beds, that show a pattern of reduced intensity of occupation during this period. Sites that had been continuously used for tens of thousands of years show thinner deposits, less frequent human visits, smaller quantities of food debris. Some sites appear to have been abandoned. The picture is not one of sudden catastrophe, but of gradual withdrawal, of people following the water, tracking the shifting margins of a habitable world. On the coasts, of course, the opposite was happening, but the coasts were disappearing. The contrast between these two processes, the flooding of the coast and the drying of the interior, is what makes the story of Australia's first civilization at this period so particularly difficult and so particularly poignant. The people who needed to retreat from the drying interior had nowhere to go but toward the coast, and the coast was not retreating to meet them. It was retreating away from them, being taken by the sea. The Sky People and the memory of catastrophe. There is a word in the Barngarla language of the Eyre Peninsula in South Australia that has been translated as the time the sky fell. It is part of a tradition that describes a period of great darkness, a time when the normal order of the world was disrupted, when the sky itself seemed to come apart and rain fire and destruction upon the land. The tradition does not describe this as a mythological event in a timeless realm. It describes it as history, as something that happened to the ancestors of the people who hold the tradition, at a specific time and place. Similar traditions exist in other language groups. They have different names, different narrative structures, different ceremonial contexts, but a common thread running through a number of them is the memory of fire from the sky, of something falling or burning in the heavens, of a time of extraordinary destruction that preceded a period of darkness and cold and the loss of familiar parts of the world. Researchers studying these traditions in the context of the Younger Dryas impact hypothesis have noted that if a fragmented cosmic body did break up in or above the atmosphere over some part of the Earth, 12,800 years ago, the effects would have been visible and terrifying to anyone within a wide radius of the event. The light of an atmospheric airburst can be seen from hundreds of kilometers away. The heat pulse from such an event, at sufficient proximity, can set fire to vegetation across enormous areas. The shockwave from an airburst can flatten trees and structures for dozens or hundreds of kilometers around the center. If the proposed Younger Dryas impactor was, as some researchers have suggested, not a single body but a cluster of fragments, the remnants of a comet that had broken apart before reaching Earth, then the effects would have been distributed across the atmosphere rather than concentrated at a single impact site. Multiple airbursts at different locations, each visible from a wide area, would have created a spectacle of extraordinary violence. From the ground, it would have looked exactly like what some of the traditions describe, a sky on fire coming apart, raining destruction upon the world below. Whether this is what happened, whether these traditions are memories of a real cosmic event, is not something that can be stated with certainty based on the current state of the evidence. The impact hypothesis remains controversial. The traditions are ambiguous. They are compatible with a cosmic event, but they are also compatible with other interpretations, including the interpretation of severe electrical storms, volcanic activity visible from a distance, or simply the imaginative encoding of general catastrophe in a specific dramatic image. What can be said is that the traditions exist, that they come from multiple independent language groups across the continent, and that they cluster thematically around descriptions of catastrophic events in the sky that correspond, in some cases, to the period we are studying. They are a form of evidence, not proof, but evidence that something extraordinary happened in the experience of the people who were living in Australia at the Younger Dryas boundary. Something so extraordinary that it was encoded in the deepest layers of cultural memory and transmitted across generation after generation for 12,000 years. This is what distinguishes the story of Australia's first civilization from the stories of other ancient cultures that suffered catastrophic disruptions. The people of Mesopotamia who experienced the flood traditions that may have inspired the story of Noah were not the oldest people in the world. The people who built the first agricultural communities of the Fertile Crescent and saw them disrupted by the Younger Dryas had been living on their land for a few thousand years at most. But the people of Australia had been living here for 65,000 years, and when something catastrophic happened to their world, they did not lose the memory of it. They did not need to write it down. They carried it in their mouths and their ceremonies and their stars, and they passed it forward through the darkness, generation after generation, until it reached us. The rock art of the Kimberly gives us something that the stone tools and the sediment cores cannot, a glimpse of how the people who lived through this period experienced it, not as data, not as evidence to be analysed, but as felt, embodied, emotionally resonant experience. The figures in the Gwion paintings are not abstract, they are specific. They are people, recognisable as people, engaged in activities, dancing perhaps, or conducting ceremony, or engaged in some other form of collective action that required the kind of coordination and shared purpose that only a complex social world can produce. These figures were made during the period when the coastal plain of the Kimberly was being inundated. Whether the people who made them were aware of this as a gradual process, a slow, steady loss of the western edges of their country, or whether they experienced it as a series of dramatic events, sudden inundations that took recognizable landmarks in a matter of days or weeks, we cannot say with certainty. But they were living in a world that was changing. They were watching their country transform, and their response, or at least one of their responses, was to make art on the surfaces of the stone that would remain. There is something in this that should not be passed over too quickly. The impulse to make art in the face of loss, to create a record of what is valued precisely because it is under threat, is one of the most specifically human of all impulses. It is the impulse that drove the cave painters of Lascaux and Chauvet, who may themselves have been responding to the uncertainties of a late Pleistocene world. It is the impulse that drives people today, in communities facing displacement or destruction, to document and preserve and create. It is the impulse that says, this matters, this is real, this should be remembered. The Gwion painters were saying, we are here. This is what we are, this is what we do, and what we value and what we look like. Remember us. And in a very real sense, in the only sense that matters, across a distance of 17,000 years, we are. What the numbers don't capture. There is a calculation that researchers sometimes make when trying to understand the scale of land loss from sea level rise in ancient Australia. The calculation is straightforward. The northwest shelf alone, the submerged plain west of the Kimberly, covers approximately 320,000 square kilometers of seafloor at depths that would have been exposed as dry land during the late Pleistocene. 320,000 square kilometers. That is roughly the area of the entire state of Victoria and New South Wales combined. Add to this the Arafura Plain, the Gulf of Carpentaria, the submerged Bass Strait region connecting mainland Australia to Tasmania, and the various other areas of continental shelf that were exposed as dry land during the glacial period, and the total figure approaches 2.5 million square kilometres of lost land. 2.5 million square kilometres. To put this in perspective, the total land area of Australia today is approximately 7.5 million square kilometres. The land that was lost to the rising sea represents roughly a third of the current land area of the continent, and it was, almost certainly, the most productive and most densely inhabited third, since it included the coastal margins and the continental shelf regions where resources are typically most abundant. The human cost of this land loss cannot be calculated with any precision, because we do not have reliable population estimates for this period. We know that people lived there because the stone tools are being found on the seafloor. We know that the coastal regions of Australia were inhabited by considerable populations in later periods, and we have no reason to think they were less inhabited during the richer ecological conditions of the late Pleistocene. But the specific numbers, how many people lived on the northwest shelf, how many in the Gulf of Carpentaria Plain, how many along the submerged coast of what is now the Timor Sea, are not knowable from the current evidence. What we can say is that the loss was vast, and that it happened to a civilization that had no way to stop it. The sea rose regardless of what the people in its path did. They could move. They did move. But moving means leaving behind the places where your ancestors are buried, the sites where your most sacred ceremonies are conducted, the specific patches of country that your family has cared for and known for generations. It means losing the connections, ecological, social, spiritual, that tie you to a specific place and make you who you are. For people whose relationship to country is not merely practical but ontological, for whom the land is not a resource but a relative, not property but a living presence, not a backdrop to their lives but the very substance of their identity. The loss of country to the sea is not just a practical challenge. It is a wound of the deepest kind. It is, in the language that Aboriginal people sometimes use when describing the loss of connection to country in the modern era, a form of grief that has no analogue in other kinds of loss. 12,000 years of that grief, 12,000 years of watching, generation after generation, as the country of the ancestors went slowly, irreversibly, into the water. The sites we haven't found. There is an archaeological site in South Africa called Blombos Cave. It is not a famous site in the popular sense. You would not find it in most general books about ancient history. But among archaeologists, it has the status of a revelation. Blombos Cave, which sits on the southern coast of South Africa overlooking what was, during the last ice age, a different kind of sea, has yielded artifacts that pushed back the known date of symbolic behavior, of art, of personal ornament, of abstract representation, by tens of thousands of years, ochre engraved with geometric patterns, shell beads strung for jewelry, bone tools of extraordinary craftsmanship, all from a period when, by the prevailing orthodoxy at the time of their discovery, humans were not supposed to be making these kinds of things. The lesson of Blombos Cave is that the absence of evidence is not the evidence of absence. The reason we did not know about the symbolic sophistication of humans 100,000 years ago was not that humans were not sophisticated at that time. It was that the evidence had not yet been found or had been lost to time and tide and the grinding of rock and sediment over millennia. The same logic applies with even greater force to the submerged Australian coast. We have found stone tools on the seafloor of the Northwest Shelf. We have not yet systematically surveyed more than a small fraction of the 2.5 million square kilometres of continental shelf that was once dry land. We have not yet developed the methodology for conducting large-scale underwater archaeological surveys at the resolution necessary to find the full range of cultural material that must be there. We have not yet found the caves and rock shelters and open-air sites of the old coastal landscape, because most of them have not been mapped, and most of those that have been mapped have not been excavated. What we might find if we were able to conduct a comprehensive archaeological survey of the submerged Australian coast is unknown. But given what we know about the richness of the surviving coastal sites, the extraordinary density and antiquity of the rock art of the Burrup Peninsula, the complexity of the cultural material from sites like Majid Bebi and the Kimberly cave systems, the evidence of long-distance trade and exchange networks that appears in the stone tools of coastal sites across northern Australia, there is every reason to expect that the submerged coast holds cultural material of extraordinary significance. There may be art there may be middens, the shell midden deposits that are among the most reliable indicators of long-term coastal settlement, that extend back tens of thousands of years. There may be burial sites. There may be the remnants of structures that we cannot currently imagine, because our imagination of what ancient Australian civilization looked like is so severely constrained by the absence of the evidence that is sitting under the sea. This is one of the central arguments for investing in the archaeology of the submerged Australian shelf, and it is an argument that Australian archaeologists have been making with increasing urgency over the past decade. The technology now exists, in the form of autonomous underwater vehicles, high-resolution multi-beam sonar, sediment coring equipment, and remotely operated vehicles with manipulator arms, to conduct systematic surveys of the seafloor at the resolution necessary to detect archaeological sites. The cost is significant, but it is not prohibitive by the standards of major research programs. The question is whether the political and institutional will exist to make it happen, because there is also an urgency to this work that goes beyond academic interest. The seafloor is not static. Currents disturb sediments. Fishing equipment drags across the bottom. Marine organisms bore into and break down organic and even inorganic materials. The longer we wait, the more of the submerged archaeological record is lost. Not to the sea, which has already taken it, but to the secondary processes of degradation and destruction that continue even underwater. The archaeological record of the submerged Australian coast is being lost, slowly but continuously, even as we speak. The living descendants and the living tradition. It would be wrong to tell this story as if it were entirely about loss. It is, in one sense, a story of extraordinary loss, of land, of animals, of coastal complexity, of the ecological richness that sustained an ancient civilization. But it is also a story of extraordinary persistence. And the most important form of that persistence is the one that is most easily overlooked. The Aboriginal and Torres Strait Islander peoples of Australia are the direct descendants of the civilization we have been discussing. They are not the remnants of that civilization, as if it were a ruin with people living in it. They are its continuation. The civilization did not end. It transformed, as all civilizations must transform in the face of change. It lost things that cannot be recovered, but it persisted, and it persists still. The knowledge systems of Aboriginal Australia, the ecological knowledge, the astronomical knowledge, the geographical knowledge, the ceremonial knowledge, the knowledge of how to live in and with a landscape rather than simply upon it, survived the Younger Dryas. They survived the extinction of the Megafaunal. They survived the inundation of the coastal plains. They survived 12,000 years of change that would have ended any civilization without the depth and resilience that comes from 65,000 years of continuous practice. The specific mechanisms by which this knowledge was preserved are worth understanding. In the absence of writing, all knowledge must be encoded in forms that the human mind and the human community can carry across generations. The most familiar of these forms is story, the narrative that encodes information in a sequence of events and images that can be remembered and repeated. But Aboriginal knowledge systems use a range of encoding mechanisms that go far beyond simple narrative. Ceremony is one of the most important. The ceremonies of Aboriginal Australia, the elaborate multi-day ritual events that bring communities together at specific sites and specific times of year, are not merely occasions for celebration or social bonding, though they are that too. They are living archives. The songs, the dances, the body decorations, the ritual objects, the specific sequences of action and speech that constitute a ceremony all carry information. Some of this information is about social relationships and obligations. Some is about ecological knowledge. The specific site where a ceremony is held may be the site where a particular resource can be found at a particular season, and the ceremony both honors and encodes this knowledge. Some of it is cosmological, about the nature of the world and the relationships between humans and the forces that govern it. The songlines are another form of encoded knowledge. These are the networks of sung narratives that traverse the continent, linking sites and landmarks through a series of sung verses that map the landscape in 3 dimensions. Not just the location of features, but their significance, their history, their connections to other features across vast distances. A person who knows the relevant songlines can navigate across hundreds of kilometers of unfamiliar country by following the knowledge encoded in the songs, reading the landscape against the mental map that the songs have provided. This is not metaphor. This is a functional navigation and knowledge transmission system that has been tested across hundreds of generations of use. The knowledge of how to manage fire in the Australian landscape, of how to maintain the productivity of country over the long term, of how different species interact with each other and with the land, is knowledge that took tens of thousands of years to accumulate, and that is only now beginning to be recognized by Western science as having relevance to the challenges of managing Australian landscapes in the 21st century. The astronomical knowledge encoded in the dreaming traditions is being studied by researchers who are finding that it preserves accurate observations about the behavior of celestial bodies, the occurrence of astronomical events, and the relationship between the sky and the seasons that are consistent with observations made over a very long period of time. It is, in a very real sense, one of the world's oldest scientific traditions, a systematic, multi-generational project of observing and recording the behavior of the natural world, preserved not in text, but in story and ceremony. The geographical knowledge encoded in the songlines, the networks of sung narratives that map the landscape and preserve information about routes, resources, and significant sites across vast distances, represents a cartographic tradition of extraordinary sophistication. The songlines are not just maps, they are mnemonic systems for storing and transmitting a complex, multi-dimensional model of the landscape and its history. They encode information about the location of water, of food resources, of sacred sites, of the paths that were walked by the ancestors, and that connect living communities to the deep past of the country. When we talk about Australia's first civilization being disrupted 12,800 years ago, we should be careful about the framing. The civilization was not destroyed. The world it had built on the coastal plains is gone, taken by the sea, along with much of the archaeological record that would tell us about its complexity and richness. The animals that shared that world are largely gone. The specific landscapes that were most productive and most densely inhabited are gone. But the people and their knowledge and their connection to country and their songs and their ceremonies, these are still here. They are still here, and they are still talking. And some of what they are saying, if we listen carefully enough, is about that moment 12,800 years ago when the sky burned and the sea rose and the world changed in ways that have not been fully understood in the 12,000 years since. The trade routes that no longer exist, one of the most significant discoveries in Australian archaeology over the past 50 years, has been the evidence for long-distance exchange networks operating across the continent in the deep past. These networks, connecting communities separated by hundreds, sometimes thousands of kilometers, were not casual or incidental. They were systematic, organized, and fundamental to the social and economic life of the civilization that maintained them. The evidence for these networks comes primarily from the distribution of raw materials in archaeological sites. Certain types of stone, particularly the fine-grained glassy volcanic rocks that produce the sharpest cutting edges, occur naturally only in specific geological formations. When the artifacts made from these stones are found at sites far from those geological formations, it indicates that either the people at those sites were traveling to the source areas, or that the material was being passed from community to community along exchange chains stretching across the landscape. At some Australian sites, stone tool materials from sources 600, 800, even 1,000 kilometers distant have been identified. This is not exceptional by the standards of other ancient cultures. Similar exchange networks are documented in many parts of the world. What is significant is the time depth. These exchange networks appear in the Australian archaeological record very early, suggesting that long-distance organized exchange was a feature of Australian civilization for a very long time, certainly predating the Younger Dryas transition. The exchange networks were not just about stone. Ochre, the red and yellow iron oxide minerals used in ceremony, in body decoration, and in art, was also exchanged over long distances. Certain ochre deposits with specific qualities were particularly highly valued, and the presence of ochre from these specific sources at distant sites indicates that the exchange networks carried culturally significant materials across the landscape in a way that was organized and maintained over generations. What the exchange networks carried that did not survive archaeologically. The specific forms of knowledge, the ceremonial rites, the marriages and alliances that were formed and renewed through the regular meetings associated with exchange can only be inferred from ethnographic records and from the structure of the living traditions that have survived. But the inference is that the exchange networks were the backbone of a continental-scale social world. They were the mechanism by which information was shared, by which ceremonial practices were coordinated, by which the genetic health of populations spread across a vast continent was maintained, by which communities that could not sustain themselves in isolation were linked into a collective system that could. When the coastal plains began to flood and the interior began to dry, these exchange networks would have come under stress. Communities that had previously been linked by routes running through coastal lowlands, routes that were now underwater, would have found their connections severed. Communities that had previously exchanged materials and knowledge with groups on the other side of what were becoming new bodies of water would have had to find new routes, new partners, new configurations of relationship. Some of this reorganization is visible in the archaeological record. Changes in the distribution of raw materials at certain sites around the Younger Dryas boundary suggest alterations in the exchange networks, shifts in which communities were exchanging with which others, changes in the specific routes by which materials moved across the landscape. These changes are not catastrophic in the archaeological record. They represent adaptation, not collapse, but they represent a genuine disruption of the social infrastructure of a continent-spanning civilization and their human cost, in broken connections, in lost relationships, in the disruption of the ceremonial cycles that depended on regular meetings of distant communities, was almost certainly significant. The trade routes that ran across the coastal plains of Sahul, the routes that connected the communities of what is now the northwest shelf with those of the interior Kimberly, that connected the populations of the Arafura Plain with those of Arnhem Land, that linked the Gulf of Carpentaria communities with those of Cape York Peninsula, are gone. They are under the sea with everything else. We know they existed because the exchange networks that are visible in the archaeological record of the surviving interior sites could not have been maintained without them. But their specific courses, the communities they linked, the materials and the knowledge and the ceremonies they carried. These are part of the lost archive of the submerged Australian coast, what we do not know and why it matters. We are in the habit, as a culture, of thinking of history as something that begins with writing. We say that prehistory is what came before the written record, and we treat it as fundamentally different in kind from history proper, as something hazier, less certain, less human in a way that it is difficult to articulate but easy to feel. The ancient Greeks seem closer to us than the ancient Australians, not because they were more recent, but because they wrote things down, and writing creates the illusion of proximity. This is a failure of imagination. The people who lived in Australia 12,800 years ago were as human as we are. They thought, they felt, they dreamed, they loved, they grieved. They told each other stories about where they came from and what the stars meant and why the world was the way it was. They made things, they cared for things, they knew things about the world that we do not know and may never recover. The fact that they did not write these things down does not make their civilization less real or less important or less deserving of our attention and our wonder. The question of what happened to them 12,800 years ago is one of the most important unanswered questions in the history of human civilization. It is important not just as a historical puzzle, interesting as such puzzles are, but because the forces that disrupted their world, sea level rise, climate change, the possible effects of a cosmic event, the transformation of ecosystems under multiple simultaneous stresses, are forces that we are beginning to understand in a new way in the present century. They are, in some cases, forces that we are setting in motion again. The sea is rising again, not at the rates of the late Pleistocene, not yet, but rising. The climate is changing again, driven this time not by the natural cycles of the Milankovitch parameters, but by the accumulated emissions of industrial civilization. The ecosystems of Australia, already diminished from their state at the Younger Dryas boundary, are under additional stress from habitat destruction, invasive species, altered fire regimes, and the downstream effects of a warming climate. The people who survived the last great disruption of the Australian continent did so because of the depth and resilience of their knowledge system, because they had, over 65,000 years, developed a way of being in the world that was capable of absorbing extraordinary change and continuing. They paid an enormous price for that continuity. They lost the coastal world that was, by all indications, the richest and most complex part of their civilization, but they did not lose themselves. We are at a moment in history when the lessons of that survival, the lessons of how to maintain a continuous, resilient relationship with a landscape across periods of catastrophic change, are more relevant than they have been since the end of the last ice age. The knowledge of how to manage fire in the Australian landscape, of how to read the ecological signals that indicate environmental stress, of how to maintain cultural and social cohesion across periods of loss and disruption, this knowledge, encoded in the oral traditions and land management practices of Aboriginal Australia, is not merely of academic interest. It is knowledge that the whole world needs. This is not a sentimental observation. It is a practical one. The civilization that survived the Younger Dryas in Australia did so because it had depth. Not just depth of time, but depth of knowledge, depth of connection to place, depth of understanding of the systems that sustain life in a variable and sometimes violent environment. That depth is still present in the communities and the traditions and the knowledge systems of Aboriginal and Torres Strait Islander peoples. The question of whether it will be listened to and learned from before the next great disruption arrives is one of the most important questions of our time. The bones the desert kept. There is something that the Australian landscape does, in certain conditions, that is remarkable and that has shaped our understanding of the antiquity of human civilization on this continent more than almost any other factor. In the right combination of dry conditions, alkaline soil chemistry, and stable sediment, the Australian earth preserves bone, not just any bone, human bone. The bones of the people who lived and died here tens of thousands of years ago. The Willandra Lakes system in western New South Wales is the most famous example. It is here that Mungo Man and Mungo Lady were found, the oldest human remains ever found in Australia, dating to between 40 and 42,000 years ago. Their discovery in the 1960s and 1970s transformed our understanding of the antiquity of human presence in Australia, and their subsequent analysis has provided information not just about when people lived here, but about how they lived and what they believed. Mungo Lady's cremation, the oldest ritual cremation ever documented anywhere in the world, tells us that the people of the Willandra Lakes had, at least 40,000 years ago, a conception of what should be done with the body of someone who had died. Cremation is a culturally specific response to death, one that requires not just a fire, but a set of ideas about what death means and what the body represents. It requires cultural knowledge, transmitted from generation to generation, about how this act should be performed. The person who cremated Mungo Lady 40,000 years ago had been taught to do so by someone who had been taught by someone else, and so on back through time to whoever first developed the practice. In the period around 12,800 years ago, the Willandra Lake system was still functioning, though it was in the process of changing. The lakes, fed by the Lachlan River, which carried snowmelt and rainfall from the slopes of the Southern Alps, had been at their most productive phase around 40 to 50,000 years ago, when the climate of this region was wetter and the lakes were full. By 12,000 years ago, the lakes were becoming shallower and more saline, their margins contracting, their productivity declining. The archaeological record from the Willandra Lakes in this period shows a community in transition. The middens, the accumulations of food debris that mark the sites of long-term occupation, thin out. The evidence for fishing, which had been a significant part of the diet when the lakes were full, declines. The bone chemistry of the human remains from this period shows changes consistent with a dietary shift. Less aquatic protein, more terrestrial resources, the dietary signature of people who were adapting to a landscape where the water-based resources they had previously depended upon were becoming less available. But they were still there. The Willandra Lakes people did not leave when their lakes began to fail. They adapted. They diversified their food sources. They developed new ways of using the transformed landscape. They maintained their social connections. The evidence of ochre processing, of the careful burial of their dead, of the maintenance of ritual practice continues through the Younger Dryas period and beyond. There are human remains from this system that date to specifically the period around 12,000 years ago. Their condition, the chemistry of their bones, the patterns of wear on their teeth, the evidence of injury and disease that is sometimes preserved in skeletal remains, tell stories that no oral tradition and no sediment core can tell. They are the most direct possible connection to the specific people who lived through the events we have been discussing. They are not abstractions. They are individuals with bodies and lives and deaths, who walked through the same world that was being transformed around them, who felt the same heat and cold, who watched the same sky, who ate and drank and mourned the same losses that we can only reconstruct from indirect evidence. There is a profound ethical dimension to this that Australian archaeologists and the communities descended from these individuals have been navigating for decades. The remains of Mungo Man and Mungo Lady, and the other remains from the Willandra Lakes, are not merely scientific specimens, they are ancestors. They belong in the most meaningful sense to the communities of Aboriginal people who are descended from them. Communities whose connection to this country runs in a continuous line back to the very individuals whose bones were found in the dunes. The question of who has the right to study those remains, under what conditions, for what purposes, and with what obligations to the descendant communities, has been one of the central ethical debates in Australian archaeology for the past 40 years. The remains were eventually repatriated to the local Aboriginal communities, who chose initially to keep them in storage rather than rebury them, pending a decision made in consultation with all relevant community groups. The process of that decision, patient, complex, conducted according to protocols that Western academia does not have, is itself a kind of living archaeology, a demonstration of the same long-term community-based approach to the keeping and care of significant things that has maintained the knowledge of the oldest civilization on Earth across 65,000 years. The geometry of the night sky. There is a feature of the Milky Way, visible from the southern hemisphere on clear dark nights, that you will not find in any northern hemisphere astronomy textbook. It is called the dark emu, or sometimes the emu in the sky, and it is not made of stars. It is made of the dark nebulae that wind through the bright band of the Milky Way, the dust clouds that block the light of the stars behind them, forming to a practiced eye the unmistakable silhouette of an emu, the long neck, the rounded body, the legs trailing behind. The dark emu is not a modern discovery. It has been observed and named and incorporated into the astronomy of Aboriginal Australia for a very long time. Different language groups have different names for it and different stories about it, but across a wide range of cultures, the figure in the dark of the Milky Way is recognized as a bird, an emu, and its position in the sky at different times of the year is used to track the emu's life cycle, including the time when emu eggs are laid and can be collected. This is not decoration. This is astronomy in the service of ecology, a celestial calendar calibrated to the behavior of a specific species in a specific landscape. When the dark emu is in a particular position at a particular time of night, it tells observers who know how to read it that the emus on the ground are in a particular phase of their breeding cycle. This knowledge translates directly into information about where and when to look for eggs, which are a highly nutritious and calorically valuable food source. The astronomy of Aboriginal Australia does not confine itself to the dark nebulae. The movements of the planets across the background of fixed stars, which were understood and tracked with great precision, encoded information about seasonal cycles, about the timing of ceremonies, about the behavior of animals and plants. The appearance of certain star clusters at certain points in the sky at certain times of year provided timing signals for activities ranging from the collection of specific plant foods to the conducting of specific ceremonies. The entire sky was, in a sense, a calendar, a multi-dimensional information system that encoded ecological knowledge in the most permanent medium available to a pre-literate culture. The sophistication of this astronomical tradition becomes even more remarkable when you consider its time depth. If the Kamilaroi story about the Pleiades, describing 7 visible sisters being chased by a hunter at a time when 7 sisters were visible, dates to approximately 100,000 years ago, as some researchers propose, then we are looking at a tradition of astronomical observation that predates modern Homo sapiens in Europe by tens of thousands of years. We are looking at a scientific tradition, a systematic multi-generational project of careful observation, rigorous recording, and accumulated understanding that is older than anything else we have evidence for in the history of human science. At 12,800 years ago, this astronomical tradition was already of extraordinary antiquity. The people who looked up at the sky on the night of the Younger Dryas boundary, whatever happened on that night, whether it was a night of ordinary stars or a night of extraordinary fire, were bringing to their observation a tradition of careful astronomical knowledge stretching back tens of thousands of years. They knew that sky. They knew what it was supposed to look like. And if something about it changed, if something fell from it, if it was filled with an extraordinary light, if the stars were obscured for days or weeks or months by dust and smoke, they would have known that it was different from anything they had seen before. The memory of that difference, if it existed, is somewhere in the astronomical traditions of Aboriginal Australia. Finding it, recognizing it for what it is, interpreting it correctly, without imposing Western frameworks onto a knowledge system that is organized on entirely different principles, is one of the most challenging and most important tasks facing the researchers who are trying to reconstruct the events of 12,800 years ago, the question of the water. One question that has not yet been fully addressed in the scientific literature on the Younger Dryas in Australia is the question of fresh water. Specifically, what happened to the rivers? The rivers of Australia are, by global standards, unusual. Many of them are not permanent features of the landscape in the way that the rivers of Europe or North America are. They flow intermittently, governed by the irregular and variable rainfall of a continent where precipitation is famously unpredictable. The Cooper Creek, which flows through the Channel Country of southwest Queensland, is one of Australia's most famous rivers, and it is dry for months or years at a time, flowing only when heavy rains fall in its enormous catchment area to the northeast. But in the late Pleistocene, the rivers of Australia were different. The evidence preserved in the sediment records of ancient floodplains, in the deposits of old river terraces, in the distribution of freshwater mollusks across the landscape, suggests that many of Australia's now intermittent rivers were, during the wetter phases of the Pleistocene, significantly more permanent and more powerful than they are today. The rivers of the Murray-Darling system, now the most important river network in Australia, but also one under severe stress from drought and irrigation extraction, were, in the late Pleistocene, considerably larger and more consistent in their flow. What happened to these rivers at the Younger Dryas boundary is a question that researchers are actively investigating. The initial indications from the sediment records of floodplains and from the pollen and charcoal records of associated lake systems suggest that the transition was not uniform. In some areas, the rivers appear to have responded to the changed climate conditions by becoming more episodic, carrying large floods during the now more intense wet seasons, then falling to very low flows, or drying completely during the extended dry seasons that the Younger Dryas appears to have promoted. In other areas, the rivers may have contracted more permanently, their catchments no longer able to generate sufficient runoff to maintain even intermittent flow. The specific pattern of river change at the Younger Dryas boundary in Australia is not yet fully documented, because the sedimentological work required to reconstruct it is painstaking and has been carried out at only a relatively small number of sites. But the general direction is clear. The freshwater systems of Australia became, during and after the Younger Dryas transition, less reliable and less abundant than they had previously been. The springs that had provided permanent water in the dry interior, and that, in many cases, have been used continuously as water sources by Aboriginal communities from deep in the past to the present day, may have been affected by changes in the groundwater recharge patterns associated with reduced rainfall. For communities whose survival in the interior depended on knowing where reliable water could be found, and whose knowledge of water sources was encoded in the songlines and the oral traditions and the ceremony of their culture, the transformation of the freshwater landscape at the Younger Dryas boundary was not an abstract environmental change. It was a direct challenge to the knowledge infrastructure that made life in this landscape possible. Water knowledge is survival knowledge in Australia. When the water moved or dried up or became unreliable in ways that had not been within living or traditional memory, the knowledge of where the water was became suddenly uncertain, and the uncertainty was life-threatening in the most literal sense. The adaptation to this uncertainty is itself a form of knowledge. The techniques for finding water in a dry landscape, the reading of plant communities that indicate subsurface moisture, the understanding of which geological formations are associated with reliable springs, the knowledge of the behavior of animals that can lead an observer to water, are encoded in the traditions of Aboriginal Australia with the same precision and the same care as the knowledge of the coastal geography and the astronomical cycles. They represent a response to exactly the kind of hydrological uncertainty that the Younger Dryas brought, developed over generations of testing and refinement in a landscape that was demanding the best possible knowledge of its inhabitants. The quiet that came after. There is a specific kind of quiet that comes after a catastrophe, not the loud, raw, immediate quiet that follows a sudden violent event, the ringing silence after a thunderclap, the held breath after an earthquake. A different kind. The quiet that settles in gradually, over years and decades and generations, as the immediate shock fades and the changed world becomes simply the world as it is. This is the quiet that came over Australia in the centuries and millennia after the Younger Dryas boundary. The fires burned and went out. The sea continued to rise, but slowly, year by year, without the episodic surges that may have marked the earliest phase of flooding. The last of the megafauna disappeared, without spectacle, their absence folding itself into the ordinary silence of a landscape that had simply always been without them. People continued to live. They moved as they had always moved, following the resources, reading the signs, maintaining the ceremonies, passing the knowledge forward. They adapted to the new coastlines, the new lake configurations, the new vegetation patterns. They developed new ways of using the changed landscape. New fishing technologies adapted to the inundated estuaries of what had once been dry plains. New plant management practices suited to the fire-adapted vegetation that now dominated much of the interior. New ceremonial forms that encoded the memories of the old world and made sense of the new one. The archaeological record of the period following the Younger Dryas shows, in many parts of Australia, evidence of adaptation and continuity. Sites that had been abandoned or less intensively used during the most stressed phase of the transition show renewed occupation in subsequent millennia. New technologies appear. New stone tool forms, new processing techniques, evidence of more intensive use of a wider range of food resources in response to the changed ecology. The demographic evidence, such as it is, suggests a recovery of population density in the interior regions once the worst of the climatic disruption had passed. But there are also signs that something fundamental had changed, something that never quite returned to what it had been. The great diversity of megafaunal species was gone, and with them the ecological relationships that had structured the landscape for millions of years. The coastal complexity, the rich, productive, densely inhabited coastal plains of Sahul, was gone, replaced by a continent with a much shorter coastline and a much smaller area of highly productive coastal habitat. The vast interior lake systems were diminished or gone, replaced by a drier, more arid interior that supported sparser populations. The civilization that emerged from the Younger Dryas transition was still extraordinary by the standards of anything else on Earth. It was still the oldest, still the most continuous, still the most deeply knowledgeable about its specific landscape of any human culture anywhere. But it was living in a smaller world than the one that had existed before. And the memory of that larger, richer, more complex world was being carried forward. In the stories of the sea taking the ancestors' country, in the traditions of the animals that no longer walked the earth, in the songs of places that were now underwater. Some things survive in memory that cannot survive in any other form. The places that are gone from the surface of the earth are not gone from the surface of the mind of a people who have spent 65,000 years learning to remember. They persist there, imperfectly but persistently, in the shapes of stories that do not quite fit the world as it now is, in the names of features that exist now only beneath the sea, in the ceremonies that preserve the knowledge of a world that most of us will never know existed. The ongoing question. There is a research station in the Kimberly, in the far northwest of Western Australia, where a team of archaeologists and geologists has been conducting some of the most exciting work in Australian prehistory. They are working on the rock art of the Kimberly, the Gwion figures, the extraordinary paintings of human-like figures with elaborate headdresses and ornamentation that are among the oldest and most technically sophisticated figurative art in the world. The dating of this art and the question of what it tells us about the social complexity of the people who made it is one of the most important open questions in Australian archaeology. What they are finding is complicating the picture of Australian prehistory in productive and important ways. The Kimberly art appears to date, in some cases, to the period around 17,000 to 12,000 years ago, right across the window we have been discussing. The figures depicted are not simple. They are complex, highly stylized, depicting people in elaborate ceremonial attire, with headdresses and body decorations that suggest a rich ceremonial and social life. They are, in every meaningful sense, the art of a sophisticated civilization, and they are being made at a time when the coastline of the Kimberly, which was then very different from what it is today, extending much farther west across what is now the shallow seafloor of the Browse Basin, was being slowly inundated by the rising sea. The people making this art were living through the beginning of the end of the coastal world that had sustained their ancestors for tens of thousands of years. The dating of the Gwion figures is itself a story worth telling. Rock art cannot be directly radiocarbon dated because rock art is made by removing material from a surface rather than depositing material upon it, and the marks left by this removal do not contain organic carbon in the way that, say, charcoal drawings or organic paint would. Instead, researchers have had to develop indirect dating methods that date the materials that have accumulated over the art surface since it was made, or that date the organic components of mud wasp nests that are sometimes found built directly over the paintings. The mud wasp nest method has yielded some of the most precise dates for Kimberly rock art to date. Mud wasps build their nests from clay and organic material, and they sometimes build them directly over rock art panels, sealing the art beneath layers that can be dated by radiocarbon and optically stimulated luminescence methods. When a mud wasp nest is found over a painting, the date of the nest gives a minimum age for the painting. The art must be at least as old as the nest that covers it, and possibly much older. Using this method, researchers have established that some of the Gwion figures were already ancient when the mud wasp nests that cover them were built. Nests dating to 17,000 years ago, covering art that is necessarily older. How much older is not yet certain, but the possibility that some of the Kimberly art dates to a period before the Younger Dryas boundary, that it was made by people who were alive before the Great Disruption, and who may have watched the beginning of the flooding of the coastal world from the rocky heights where they made their extraordinary images, is not a remote one. What they made in the face of that loss was art. They made it on the rocky outcrops and shelters of the inland Kimberly, on the surfaces of a landscape that was not going to be taken by the sea, on stones that would still be there long after everything on the coast was gone. They were, in a sense, making an archive. Not a deliberate archive in the way that a library is deliberate, but an archive nonetheless, a deposit of cultural meaning in a medium that would outlast the world that produced it. Those figures look out at us across 17,000 years of time from surfaces that the sea could not reach. They are a reminder, as powerful as any reminder in archaeology, that the people who lived in this landscape before the flood were not simple, were not primitive, were not the vague, featureless ancestors of a later civilization. They were fully human, fully complex, fully alive to the world in all its richness and terror. They were us, looking at the same sky, asking the same questions, carrying the same weight of consciousness and memory and hope. What happened to their world 12,800 years ago, we do not fully know. The sea rose, the climate shifted, the great animals disappeared. Something may have fallen from the sky. The world was transformed in ways that were felt as catastrophe by the people who lived through them, and that echo in the oldest oral traditions on Earth, as the memory of a time when everything changed. The question of exactly what happened, and exactly when, and in exactly what sequence remains open. It is being investigated with increasing urgency and increasing sophistication by researchers who understand that the answer matters. Matters not just as history, but as a window into the processes that are capable of transforming civilizations and into the conditions under which civilizations can survive. The oldest civilization on Earth survived it. They carried their knowledge through the fire and the flood and the cold and the dark, and they brought it forward, and they are still here, and they are still talking. We would do well to listen. What the water holds. There is something that happens when you fly over the northwest coast of Australia on a clear day and look down at the sea. The water there is shallow enough and clear enough in places that you can see the seafloor from altitude. You can see the old river channels tracing their way across the sand, heading toward the edge of the shelf where the seafloor drops away into the deep ocean. You can see the variation in the bottom, the different colors and textures that indicate different sediment types, different ecological zones, different histories. If you know what you're looking at, what you see is a landscape, an ancient landscape covered by a thin skin of water, preserved in a kind of suspended animation by the cold and the dark and the pressure of the sea above it. A landscape that was, 12,000 years ago, alive with the sound of wind and birds and the footsteps of people who knew its every feature, and had names for every valley and every waterhole and every rocky outcrop. Underwater archaeologists who have dived on the seafloor in some of these areas describe a quality of stillness, an eerie preserved quality to the landscape beneath the sediment, as if the world that was submerged is still there, waiting. The hills of the old coastline still rise from the flat shelf. The riverbeds still run their old courses. In some places, remnants of old terrestrial surfaces are preserved under the sediment, containing organic material, wood, shell, charcoal, that can be radiocarbon dated and that tells stories in the language of chemistry about what this place was like when people lived here. Those stories are beginning to be told. Slowly, painstakingly, with the difficulty and the expense that working underwater always entails. The archaeology of the submerged Australian coast is beginning to reveal what it has been holding in the dark for 12,000 years. Not quickly, and not completely, and not in anything like the systematic way that would be needed to fully understand what was lost. But beginning. Each new fragment of evidence, each stone tool pulled from the seafloor, each sediment core that reveals a buried land surface, each sonar survey that maps the outline of an ancient river valley, adds something to our picture of a world that was extraordinary and that ended in ways we do not fully understand. Each new analysis of an oral tradition that reveals an accurate memory of a specific geographical event adds something to our understanding of what that world meant to the people who lived in it. The picture that is assembling itself, piece by piece, from all of this evidence is one of a civilization of considerable complexity and sophistication, occupying a vast and varied landscape, maintaining intricate networks of knowledge and exchange and ceremony across enormous distances, with a depth of connection to place and to the natural world that has no parallel in any other human civilization we know of. It is a picture of a world that, at 12,800 years ago, was subjected to stresses, of sea level rise, of climate change, of possible cosmic disruption, of ecological transformation, that would have been survivable only by the most resilient and adaptable of human cultures. And it is a picture of a civilization that, against all odds, survived. The survival was not without cost. The coastal world, the richest and most complex part of the civilization, went under the sea. The megafauna went away. The interior lake systems shrank. The world that emerged from the Younger Dryas transition was a diminished version of what had existed before, in terms of its ecological richness and its sheer physical extent. But the people survived. The knowledge survived. The connection to country survived, transformed but continuous, across 12,000 years of history that most of us know nothing about. It survived through everything, through the fire and the cold and the flood and the long diminishment of a world coming to terms with its losses. It survived and it continues to survive, carried in the minds and the mouths and the ceremonies of the oldest civilization on Earth. The world Australia was not alone in losing. The story of what happened to Australia 12,800 years ago is not an isolated story. Around the planet, at the same moment in geological time, other civilizations, other complex, sophisticated, long-established human communities were experiencing their own versions of the same disruption. In the Fertile Crescent of the Middle East, the Natufian culture was in the process of making the transition from complex hunter-gathering to the first experiments with agriculture. The Natufians had developed some of the characteristics we associate with settled civilization: permanent or semi-permanent villages, cemeteries, art, evidence of stored food. They were, in the estimation of many archaeologists, on the verge of the agricultural revolution that would, in the following millennia, give rise to the first cities of Mesopotamia. And then the Younger Dryas arrived, and the rain stopped, and the warm conditions that had made the experiment possible retreated for more than 1,000 years. The archaeological evidence from Natufian sites at the Younger Dryas boundary shows a reversal, a return to more mobile, less settled patterns of existence, a reduction in the scale and permanence of occupation sites, evidence of population movement away from the areas that had supported the early experiments with cultivation. The agricultural revolution was delayed, not stopped permanently. When the Younger Dryas ended and the climate warmed again, the experiments resumed, and within a few thousand years, the first true agricultural communities appeared in the Levant. But the transition was disrupted, set back, forced to begin again under conditions that the original experimenters never lived to see. In North America, the Clovis people, the best documented of the early American cultures, disappear from the archaeological record at the Younger Dryas boundary. Their distinctive fluted spear points, found at sites across the continent from Alaska to Patagonia, suddenly stop appearing in the record at precisely the time when the Younger Dryas begins. Whether this disappearance represents actual population collapse, rapid cultural transformation, or simply a change in technology that makes the archaeological signature unrecognizable, is debated. But the timing's exact. The Clovis culture is there, and then it is not. And the moment of its absence coincides with one of the most abrupt climatic transitions in the Holocene record. In China, the Liuzhui culture of the Yangtze River Valley shows evidence of disruption at the Younger Dryas boundary. In the Indian subcontinent, sediment records from the Indus Basin indicate significant changes in the monsoon system that delivered the region's rainfall, with implications for the human populations that depended on it. In Europe, the Magdalenian culture, the creators of the cave paintings of Lascaux, Altamira, and Chauvet, perhaps the greatest flowering of artistic achievement in the Paleolithic, contracted significantly at the Younger Dryas boundary, with population movements away from the northern regions that the Magdalenians had colonized during the warmer conditions of the preceding millennia. The Younger Dryas was, in this sense, a global event with global cultural consequences. It was not just Australia's catastrophe, it was humanity's catastrophe, a moment when the civilizations that had been developing in many different parts of the world under the relatively benign conditions of the late Pleistocene warming were suddenly subjected to conditions that tested their resilience to the limit and, in some cases, beyond it. What makes the Australian case unique is not the disruption, it is the survival. While the Natufians were set back by centuries, while the Clovis culture disappeared from the record, while the Magdalenians contracted to their southern refugia, the Aboriginal civilization of Australia persisted. It was damaged, it lost its coastal complexity, it lost its megafauna, it lost the richest and most productive parts of its territory. But it did not collapse, did not disappear from the archaeological record, did not leave a gap that had to be filled by a new culture with no connection to what came before. The reasons for this persistence are complex, and they have to do with the specific nature of the Australian civilization, with its extraordinary depth of accumulated knowledge, its sophisticated systems for transmitting that knowledge across generations, its long experience with the variable and extreme conditions of a continent that had never been easy to live in. But they also have to do with something more fundamental, the specific character of a relationship with country that had been developed over 65,000 years, a relationship so deep and so specific and so resilient that even a disruption of the magnitude of the Younger Dryas could not break it. This is what distinguishes the story of Australia's first civilization from every other story of ancient civilization we know. The others are stories of rise and fall, of flourishing and collapse, of civilizations that built themselves up and then came apart under the pressures of external disruption or internal contradiction. The Australian story is different. It is a story of endurance, not of triumph, not of uninterrupted prosperity, but of the maintenance of connection across time through everything, across a depth of history that makes everything else we call ancient look recent. The last thing the elders said: there is a protocol in Aboriginal Australian culture around the telling of certain knowledge. Not all knowledge is available to all people. Some knowledge is held by specific custodians whose responsibility is to keep it and pass it to appropriate others at appropriate times. Some knowledge is held collectively by language groups and ceremonial communities, and is transmitted through complex ritual processes that have no simple equivalent in the tradition of written scholarship. This protocol is not a barrier to understanding. It is a form of wisdom about how knowledge works, about the fact that certain kinds of knowledge can only be transmitted in certain kinds of relationships, and that the attempt to transmit them outside those relationships inevitably loses something, distorts something, misrepresents something. The researchers who have been working most productively with Aboriginal communities on questions of ancient history, on the sea level traditions, on the astronomical traditions, on the geological and ecological knowledge encoded in the oral traditions, have learned this lesson. They have learned that the most productive approach is not to extract the knowledge from its context and translate it into the language of Western science, but to work in genuine partnership with the communities that hold the knowledge, to develop methods of documentation and analysis that are responsive to the protocols of those communities, and to produce work that serves the needs of those communities as much as it serves the needs of academic research. This is slow work. It requires trust, and trust requires time, and time requires sustained commitment. But the results of this approach are, in every case where it has been tried, more complete and more accurate than the results of the extractive approach that characterized much of early Australian anthropology and archaeology. The elders who hold this knowledge are not passive repositories. They are active thinkers, critical interpreters of evidence, contributors to the collaborative enterprise of trying to understand what happened to their ancestors and to the world those ancestors inhabited. They bring perspectives and methods that Western science, for all its power, does not have. They bring the knowledge of what the landscape feels like from inside a culture that has been living in it for 65,000 years. They bring the knowledge of what the stories mean that Western researchers, working only from text and artifact, cannot recover. When the elders talk about the old country that is now under the sea, they are not speaking abstractly. They are speaking about places that their families are from, that their ceremonies remember, that their songs map. They are speaking about a loss that is not historical in the abstract sense, but is personal, familial, continuous. A loss that is present in their cultural life in a way that nothing that happened 12,000 years ago has any right to be, and that is there anyway, carried forward in the way that all things that matter too much to lose are carried forward. When they say that the sea took the country of the ancestors, they are saying something that is verifiable by geology and oceanography. When they say that the ancestors knew things about the stars and the land that are worth knowing, they are saying something that is verifiable by astronomy and ecology. And when they say that the memory of what happened 12,800 years ago is still alive in the ceremonies and the stories, they are saying something that researchers are only beginning to be in a position to understand. The question of what wiped out Australia's first civilization 12,800 years ago does not have a single simple answer. It was the sea. It was the climate. It was possibly something that fell from the sky. It was the loss of the megafauna that had shaped the landscape for millions of years. It was the transformation of the ecology that had sustained a civilization for 65,000 years. It was all of these things working together in the way that catastrophes usually work, not as single events, but as systems failures, as the overwhelming of resilience by the simultaneous pressure of too many stresses at once. But it was not, in the end, a complete destruction. Something survived. The oldest continuous civilization on Earth survived, carrying its knowledge through the fire and the flood, maintaining its connection to country through the loss of the coast and the disappearance of the giants, transmitting its memory of the world as it was through 12,000 years of the world as it became. That survival is the most remarkable fact of the story we have been telling tonight. Not the catastrophe, but the persistence. Not the loss, but what was kept. There is one more thing worth holding as the night deepens and the story settles into stillness. The world that existed before the Younger Dryas boundary, the world of Sahul, with its vast coastal plains and its inland lake systems and its extraordinary megafauna, did not simply disappear from the minds of the people who saw it change. It became the deep past, the country of the ancestors. The time when things were different, when the sea was farther away, when the animals that had gone from the world were still walking through it. It became, in the specific sense used by Aboriginal philosophy and cosmology, part of the dreaming. Not a historical past located at a specific point in time, but an ever-present dimension of reality that underlies and sustains the present world, accessible through ceremony and story, never fully gone. This is a profoundly different relationship to the past than the one that Western civilization has developed. For us, the past is behind us, a receding distance, growing more obscure as time accumulates between us and it. For the traditional knowledge systems of Aboriginal Australia, the past is not behind you, it is beneath you. It is in the country you stand on, in the stories that explain the shape of the land, in the ceremonies that reenact the foundational events of the world's creation and maintenance. The past is not gone. It is present in a different register, accessible to those who know how to attend to it. This is why the sea level traditions are not felt by the communities that hold them as historical curiosities about events that happened long ago. They are felt as the ongoing reality of a connection to country that includes the country that is now under the sea. The ancestors who lived on those plains are not remote figures from a distant past. They are near in the way that all ancestors are near in a tradition that does not put the past behind you. Their country, and the country now under the water, is still part of the living map of the world, still present in the ceremony, still accessible in the dreaming. This is the final mystery in the story of what happened to Australia's first civilization 12,800 years ago. Not what the physical mechanism was, whether it was primarily the sea or the climate or something from the sky or some combination of all three, but how it was survived, how a people absorbs a loss of that magnitude and continues, how the knowledge of a drowned world is kept alive across 12,000 years, how the grief of losing country becomes, over time and through the work of ceremony and story and song, something that can be carried rather than something that crushes. The answer, as best as it can be articulated from outside the tradition, is that the knowledge was never allowed to become merely historical. It was kept alive in the present tense of ceremony and song as a living relationship with a living world. A world that includes, in the cosmology of the oldest civilization on Earth, the country that lies beneath the waves as well as the country that lies above them. Rest now in the knowledge that the oldest story on Earth has not been lost. It has been carried. It is still being carried tonight in the minds and the songs and the ceremonies of the descendants of the people who watched the sea take the country of their ancestors 12,800 years ago. The water came for the land, but it could not reach the memory. It could not reach the song. Rest now. Let the images settle slowly, like sediment falling through still water, each layer drifting down to rest upon the last, building slowly into the record that the earth keeps of everything that has ever happened upon its surface. The red cliffs of the old Kimberly coast in the low light of a morning that happened 12,000 years ago. The giant wombat moving through grassland that is now under the sea. The people standing at the water's edge, watching the horizon where the country of their grandparents' grandparents now shows only as a shimmer at low tide, a slight color change in the shallow water where the old riverbed still runs its course beneath the waves. The sea has its own kind of memory. It holds the shapes of the old world in the dark below its surface, in the sediment and the sand, in the old channels and the buried shores. It keeps its record quietly in the dark. The old rivers still flow down there in the direction they always flowed, though there is no sky above them now and no wind moves the surface of the water that covers them. The old shorelines are still there, in the subtle color changes of the seafloor, in the slightly different texture of the sediment where the beach once ended and the dunes began. The places where people lit fires and sat in circles and told each other the stories of their world are still there, under everything, waiting in the patient way that only the very deep past can wait. There are children alive today who are descended in an unbroken line from the people who sat at those fires. They carry in their bodies and in their traditions and in the specific quality of their relationship to this continent something of what those people were. Not everything. Too much has been damaged, too much has been broken by the disruptions of the past 2.5 centuries. But something, enough, the thread holds. And what the thread holds is not just history. It is not just memory. It is a way of attending to the world, a way of listening to the landscape, of reading the signs that the land gives to those who have learned its language, of understanding the relationship between the sky and the season, and the behavior of animals and the movement of water across the face of a continent that has been inhabited with care and intention and deep knowledge, for longer than human writing has existed anywhere. It is a way of being in the world that took 65,000 years to develop, and that survived 12,800 years ago when the world that had been built for largely ceased to exist. And that is still present, still practiced, still being passed from one generation to the next in the oldest act of cultural transmission on the surface of this earth. And on the land above, in the ceremonies and the songs and the stories that have been carried forward through 12,000 years of human time, another kind of memory persists. Patient, precise, still speaking to those who have learned how to listen about a world that ended and the people who survived it. Sleep well. The oldest story on Earth is still being told. It is being told tonight somewhere in the country of Australia in a language that most of the world will never hear, by voices that carry within them the accumulated weight of everything that has been discussed here. It is being told in ceremony and in song and in the specific careful knowledge of where the water is and where it was and what the sky looks like before the rain comes and what the stars mean in the season when the emu eggs are ready to find. It is a story without an ending because the people who tell it are still here, and the country they tell it about, the country above the water and the country below, is still here, and the relationship between them is still alive. That is the most extraordinary fact in all of this, not the catastrophe, the continuation. 12,800 years. The stars have moved, the coasts have changed, the animals are gone, but the voice remains. It was there before the flood, and it is here after. It will be here still. Sleep well.